Good morning, everyone, and welcome to the 2020 Pacific Northwest Pretreatment Workshop. We are very happy that you guys are all able to attend today. Welcome and thank you. It is 8:01, so we're going to get started. We have some really great presentations lined up for today. Today's going to be more of the, it's going to be a technology day. So a lot of talk about different technologies in the pretreatment world. So I'm pretty excited about it. We wanted to mention before we get started that if you need CEUs for this workshop, please remember to participate in the polls that we do at the end of each presentation. That way we can record your participation and we can give you 0.1 CEU for each 1 hour session. You may need to, if you didn't attend any of the days last week, I wanted to mention that you may need to minimize your screen in order for the polls to show up. I'm not sure why excuse me. Excuse me, I'm not sure why this happens to some folks, but if you do not see the poll pop up on your screen, try minimizing it. If that doesn't work, you can use the question or chat box to let one of the moderators know. My name is Andrea Swan, and I'm the Pretreatment Coordinator for the City of Sumner, Washington. And we have the other moderator this morning is Ari DeHoop. He's the Pretreatment Coordinator for the City of Klamath Falls. So we will be here monitoring the questions box and the chat box, and we'll work through any issues with the poll with you directly. With that, we wanted to mention that you can use the Q&A box for questions for each of the presenters. Some of them may want them real time. Some of them may want the questions held for a Q&A at the end of their presentation. When you put up a question, we'll let you know when we expect to ask the speaker and what their preference is. We're going to try to give a 5-minute break, at least between the second and third presentation at 9:55. We will attempt to take more breaks than that, quick breaks, if time allows. We'd also encourage you to complete a survey when we send it over to you guys. Your feedback is very valuable. And finally, just a reminder that all of the presentations will be posted to our website, as well as each recorded session and any handouts that the presenters give to us that go along with their PowerPoints. We do not have a date for posting the recorded sessions or the presentations, but it will follow in the days after the full workshop ends, and that will be on our website. Today we have Dan Parnell joining us to talk about, to share a primer on pretreatment technologies. At 9, we have Bob Smith with Cambrian Technologies. He's going to present Understanding High Strength Waste and Appropriate Treatment Options. After our quick break, we're going to welcome Joshua Ballantyne to share about enhancing pretreatment programs with smart utilities and digital solutions. And we'll wrap up today's session with Betsy Hansen from Swift Comply sharing pretreatment program management software analysis. We want to remind you guys that we have put together a little social event, a virtual networking event this Thursday, November 12th at 5:30 p.m. Pacific Standard Time. We encourage you guys to join us with a beer in hand or your beverage of choice and come talk about pretreatment and other topics. Catch up with colleagues that you haven't seen in a while. We will have breakout rooms. The topics are listed here: public education and outreach, program dynamics, and pretreatment during COVID-19. If you'd like to join the event, please RSVP to me directly before Wednesday the 11th. And with that, we are going to introduce Dan Parnell. He is with the City of Portland, Oregon. Welcome, Dan. Thank you so much for joining us today.
Thanks, Andrea.
Oh, there you go.
So,
all right, I'm trying to get Dan.
Waiting to be able to see
yeah.
screen.
How about now, Dan?
All right, I got it.
Okay.
Yep.
Wonderful. Okay,
we got it up.
Yeah, we'll hand the reins over to you. And I can see your screen. Yep, there we go. Okay, thanks again, Dan.
Perfect, thank you. All right, hi, I'm Dan Parnell, Industrial and Permitting Manager for the City of Portland. One of the departments that I manage is the Industrial Pretreatment program, and I've been doing this for about 20 years. This presentation essentially is based on my experiences with treatment systems. You know, I started out actually as a former biology and chemistry teacher, went into wastewater and then into industrial pretreatment. Basically, like all of us do, we learn treatment systems through experience. So it's basically, you know, doing a lot of research, asking a lot of questions at different facilities and figuring out how these things work. So I'm kind of presenting not as this from an engineer's perspective, just more of, hey, this is what I've learned over 20 years of doing this. All right, for some reason it is not advancing. There it goes. All right, so essentially we're going to go over a bunch of different technologies, talk about the concepts behind the treatment technologies, applications for each of those systems, and then what are some inspection basics. And inspection basics are going to be questions. You know, last week listening to one presentation, and the speaker talked about the importance of just asking questions and follow-up questions. And really, I mean, that's been my experience as well. I mean, that's how you conduct a really thorough inspection. So I've kind of gone through and just redid this presentation with questions in mind. These are different types of technologies. It's a pretty large presentation, so let's get started with it. First off is equalization. Okay, so equalization, basically all you're doing is you're providing a lot of capacity that allows variable waste streams and variable flows to collect and commingle. So you get more uniform characteristics in the waste streams, as well as a more uniform flow rate. So it's used in industries that have variable flows, variable organic loadings, used a lot for pH, and it can be used for if there's temperature issues as well. It's a great place to settle out water and let the temperature drop down to level. So you'll find these typically before treatment and after treatment. All right, so here's one before. First picture is one before treatment, allows for a uniform waste stream. This is a noodle manufacturer in Portland. So if you're doing any type of food or beverage manufacturing, you have to do acidic and alkaline washes. So this allows acidic and alkaline washes to commingle. You get some natural pH adjustment there, but also, you know, you have these peak flows coming from these washes that the treatment system can't handle. So this allows you to control those loadings downstream. The picture to the right is before discharge. So this was a large coffee roaster. I used to work in Jacksonville, Florida. That's where I got started in pretreatment. This was a large, we were having issues from their discharges with, you know, essentially BOD, or we measured it in COD. And, you know, instead of putting organic treatment in, what they did is they just put a really large equalization tank in, and were able to essentially feed effluent from that at a constant rate and get rid of peaks. And I'll show you a graph that kind of shows that effect. So here's a graph. Blue line is before equalization. You get all these peaks that can be troublesome. And then after equalization, you get this nice smooth flow coming to us. And again, a nice smooth organics loadings. And you do that, you know, the reason why you would do this is just a lot cheaper than putting in treatment for BOD, which is pretty costly. So there's definitely a cost benefit for an industry, usually an equalization to even out flows or organic loadings. Some inspection tips, you know, stuff that I've run into is that they're properly mixed. You know, if they're solids, those solids are going to settle out and they're going to become an issue at the bottom of the tank. Also, if there's a lot of organics in there, you'll have anaerobic degradation. So this mixing introduces oxygen. And if you have anaerobic degradation, you get the low pH issues, you get odor issues as well. And so you can, you know, do aeration. You can, as far as mixing, you can use a mechanical mixer like the picture you see there to the right, or you can throw in some aeration. Now, if it's a categorical facility, you know, one of the questions you might ask, are regulated and non-regulated waste streams commingling in the equalization tank? And if they are, have the categorical limits been adjusted accordingly, either using flow weight average or combined waste stream formula? All right, filtration. So filtration, essentially you're removing pollutants from the waste stream based on particle or molecular or ion size. It's, again, another widely used treatment system. It can be pre or post step. Technology used depends on particle size, density, wastewater flow rates, and loadings, which is really true of all types of treatment technologies. They're based on flow rates and loadings. Picture here is a centralized waste treater. These are the equalization tanks here. And this is actually the filter, and we'll talk about that filter a little bit later. This is a common graphic that you can find on a lot of different vendors. It's essentially the same graphic. This basically shows you the particle size range up here. This is in microns. This is in angstrom. And, you know, an angstrom essentially is the unit that's used to measure atomic radii is used in angstrom. So filters can get pretty darn small. And then down here kind of shows you for the different sizes of particles, the type of technologies that you're going to use. All right, so filtration. First off, we'll talk about insoluble solids here. You know, just screens, basic screens, basket strainer, rotary screen. Both of these are food manufacturers. These are installed basically for the purpose of optimizing treatment systems that are further down the line. You don't want these solids going to the further down the treatment systems. One is it can interfere with the treatment system, and also just can overload that treatment system with particles that can be much more cheaply brought out by using something as a basket strainer or a rotary screen. Here talking about filters, you have something like a disc filter. So you see the black cartridges to your left. Those are full of a bunch of different discs which have filters on them. They have multiple cartridges, so it'll increase the capacity of it. And also, you know, if one of those fills up, if you're continuously discharging and you need to take one of those offline to maintain, you got other filters too that keep on working. Two pictures to the right are from an industrial laundry. Excuse me. And the first one are bag filters, so those are 50 microns. So 50 microns in a bag filter is typically going to be found on the pre-treatment side. It's before the treatment. It's a fairly large pore size. And then that feeds into these equalization tanks that you see right here. And from the equalization tanks, it goes into these ceramic membranes. So these ceramic membranes, and we'll talk more about membrane filters in a little bit. What they're doing is, you know, they're removing emulsified oils and grease. And the whole intent of that is, one is to help meet oil and grease limits. But the other one is this allows them to get clean enough water where they can reuse it in the laundering processes. And a lot of these membrane filters, that's essentially what you're going for, is less compliance and maybe more of trying to reuse that water. All right, centrifuges. So we actually use this centrifuge is utilized at an industrial or centralized waste treater. It's a pre-step for any type of loads that come in that are really heavy and solids. They can get those heavy solids out, removed fairly quickly through the centrifuge. All right, filtration inspection tips. How are the solids removed from the filter? And again, anytime we talk about solids, you kind of get the same theme. You'll see the same theme. What's the hauling frequency? What's the destination? Do you have hauling records? Review the hauling records. Do the solids need to be dewatered prior to disposal? And if they do, they're really wet solids, you're not going to haul them. Where does that water portion go so you don't have to haul it? And if you look at the quiz here, this is not part of your poll. Should be pumped back to the pretreatment. Many times, any dewatering from filters is going to have particulates still in it, and it should be going back to the treatment system. Threw in some technology throughout your terms. I really don't want to go over those, but if you ever want to reference, that was the intent there. So, I was going through this thinking there's just not a whole lot to talk about when it comes to filters. I mean, it's tough to really screw up filters. And then I remembered 2017. So you get a bonus case study. 2017, City of Portland, a portable toilet company decides instead of paying somebody else to treat their wastewater, they're going to install some treatment on site at their facility and get an industrial wastewater discharge permit. You look at the diagram here. This is a screen. So it's a screen. And from the screen basically catches all the large solids. This is about a month. This is the pre-permitting inspection. So our permit writer goes out there with their compliance inspector, make sure everything that they've put in their permit application is accurate. This is what the screen looks like. Solids are going to collect on the screen. They're going to use a rake to remove those solids and then put them in some type of dumpster. So everything looks fine to go. So about a month later, after we're out there, the city pump station fails on multiple days due to clogging. And this is the debris that they pulled out of here. So you see some bandanas, you see earplugs, a lot of this white material. And I have no idea what it is, but I was told it's called like a backing off of a tape called mule tape that's used in construction. So a lot of construction related materials. I would have to say is this went on for like maybe 4 or 5 days before we were ever contacted. So once we were contacted, asked about any new permittees in the area. We did have one new permittee. We've gone out there, and this is what we found. The box spring, or the box screen, had a fairly large slit cut in it, allowing solids, as you can see the solids hanging off, large solids to be discharged through that. So from this was like the most epic fail in pre-treatment permit history. The very first day that they discharged, our pump station failed. It failed every day that they discharged. They had to maintain discharging records, and every day that they discharged, the pump station failed. We made them fix the screen once we figured out what they had done, and once the screen was fixed, our pump station stopped failing. We took the pictures of those debris pulled from the pump station to the manager of the facility and says, oh yeah, that stuff's inside of our dumpsters because they use them at construction sites. So construction workers, obviously don't have a lot of respect for portable toilets. I'm sure that's an issue that portable toilets have to go through their whole life. So they throw this stuff in there. So we assessed $90,000 in penalties for interference. You got to think about the poor millwrights that actually had to respond to this and pull that stuff out of those pumps. You saw needles in there. And this was happening, like in the middle of nights type stuff. It was pretty terrible incident. They did appeal it, and we went to a code hearings judge. And so I am going to quote to you what their attorney said to the code hearing officer. He basically said that the screen would not, and this is the attorney, the screen would not allow large turds to go through. So they cut the screen in, they cut the hole in the screens just so they could push the large turds through, but they didn't allow anything else to go through, only large turds. And unfortunately, that was such an eloquent presentation from an attorney that the code hearing officer, even with all the other evidence that we had, said, okay, yeah, you guys we didn't prove that you guys had caused it. And actually, we lost that case. And they did not have to pay the $90,000 in civil penalties. So I think it's all about eloquence and presentation. So if you're offended by me using the word turd, again, a code hearing officer feels that it's perfectly fine and will actually be a successful strategy in an appeals case. All right, so let's talk real quick about solids removal for soluble solids. So previously we talked about insoluble solids. Now let's talk about soluble solids. It's typically a polishing step. It's used to achieve, in some cases, stringent effluent limits. Other cases, it may be used just to produce effluent that can be reused. Two basic categories, media and membrane filtration. For media, one type is ion exchange. You'll see these blue canisters. For some reason, blue is like the color of choice for filtration. They're full of all these little resin beads, and these resin beads, if you look here, have a charge on them. So the resin beads have a positive charge, which is a hydrogen ion, a negative charge, which is a hydroxide ion. It's used a lot in just water treatment. So the graph here really shows for water treatment, but it works the same way for wastewater pollutants. So this is just salt if you're using to remove salt from a waste stream. Essentially, it's a replacement, just a simple replacement. The sodium has a positive charge, it replaces the hydrogen. The chlorine has a negative charge, it replaces hydroxide. So you have water essentially coming out. So sodium chloride solution coming in, water going out. The resin, essentially you have bazillions of these resin beads. Eventually, all the resin beads no longer have any more hydrogen or hydroxide to be replaced. They've all been filled with the pollutants, so they have to be regenerated. And that's done by just simply washing it with acid or caustic. You wash it with acid, that puts the hydrogen ions back on. You wash it with caustic, hydroxide ions. But what happens is you end up getting these discharged. So typically, if a facility is doing this, a vendor comes in and replaces these cartridges for them, and they take those cartridges someplace else and do the regeneration. If they're not doing if they're doing the regeneration at the facility itself, then you need to ask them, well, how are you doing with the effluent from the regeneration? And you should also be doing some type of neutralization with it. So another media is zeolite. So this is from a centralized waste treater, and they use this. They have some pretty tough metal ion limits as a centralized waste treater. So they use this as a polishing step. It's a natural clay. It's very porous, so it's got a lot of surface area for adsorption. It naturally attracts cations. So cations just from the natural clay. And they can also modify it in different ways, chemically modify it so it can attract other types of ions and organics as well. All right, membrane filtration. So these are the different types of membrane filtration. It's all based on particle size. These are the microns. Goes down to reverse osmosis. This is basically how it works. So your wastewater is going into these tubes. These tubes have a semi-permeable membrane. Basically means it has pores that let certain things in, other things it doesn't let in. There's a lot of pressure. The water leaves it, and obviously very small ions, depending on the pore size, will also leave this as well, and that's called the permeate. So the water comes out, clean water comes out. The concentrate, which is, again, where all the pollutants are, basically passes through. So this is called this is a CWT, and you use this filtration. This is called a VSEP, a vibratory separator. So you got all these pores, you got pollutants going through it. If you're dealing with pores, the pores can get clogged. It's called getting fouled. The membranes get fouled. this is a VSEP, it's a vibratory separator. And so basically it moves a lot, and that vibration basically cleans the pores. So it has you can use it more before you actually have to go in and service the membrane. So solids removal, if it's a media, inspection tips. How do you determine when the media is spent? Again, media is essentially going to attract ions to its surface, and after a while, that surface is completely filled, and it's not going to accept any more ions. Now, it doesn't get clogged, the water can still pass through it, so how do you know when your media is spent? What do you use to determine that? How is the spent media managed? Do you manage it on site? If you manage it on site, well, what are you doing with those ions that you've pulled off of it to reuse it? Or does a third party take it off site? If it's a membrane, how is the concentrate managed? You're pulling this concentrate, this water that's full of pollutants. Where are those things going? Are you discharging them back into the sewer system? Or are they being managed in some other way? And then what's your membrane maintenance frequency? Remember, membranes have pores. Eventually those pores foul, and they do need to be cleaned. All right, oily water treatment. So just to let everyone know, during the pandemic, most of my verbal communications has been grunts, which really isn't too different from before the pandemic, but it's intensified. So I haven't spoken this much in a long, long time. So if I stop talking, it's because I've lost my voice. All right, so concept, oil, water don't mix. Oil's more dense than water. You give it an environment that allows for the oil to physically separate from the water fraction. Two forms of oil, free oil, emulsified oil. The difference is basically the droplet size. Oil becomes emulsified when there's some type of agent or activity that makes it into really small droplets, which are much more easily dispersed. It doesn't make them soluble. They still don't mix, but they become more like a suspension, I guess would probably be a good analogy. It becomes suspended in the waste stream, and it's more difficult to remove them when that happens. Wide range applicability in the industry in industries. So for free oil, very simple, provide some type of oil water separator. The oil water separator has capacity. You have time, it comes through, it's a quiescent zone that allows these large droplets to float up to the surface. Here you have a discharge pipe that allows oil to, slowly drop off and go into a storage tank. You have a weir here, the effluent then overflows and goes, this one actually went down to further treatment. So this is a centralized waste treater. This is really important. In industrial applications, oil loadings are an issue. So, if you have a heavy oil generator, having your typical in the ground type of oil water separator can be difficult because essentially you're producing too much oil to be able to go in there and, physically remove it. So having some way where it's automatically draining off is key for these to work. I mean, it'll work like we're talking about an auto shop. It works because you're not producing that much oil. But if you're doing it from an industrial perspective, there'd be a lot of loadings from oil, and you'd have to maintain these things a lot if you didn't have some type of way to collect the oil continuously. Different separation aids. This is a coalescence plate. Basically, it's made out of plastic, has a lot of surface area. Oil does not attract to water, but it does attract to plastics. So that it helps bring that out, helps bring the oil out of the water fraction. Here's an adjustable oil skimmer trough. So here the oil skims off. This is how the oil leaves once it gets here. And you have an effluent weir over here. Also have a rope skimmer. So the rope skimmer, again, has kind of like a plastic type of rope, which attracts oil. It continuously is going, it's revolving through here. It comes up into this mechanism. There's actually a squeegee in here, and the squeegee squeezes oil off into another container. All right, so let's talk about dissolved air flotation. So the concept is you're going to add chemicals to bind these oil droplets together. And then you're going to put a waste stream into a tank with some pressurized air into a tank, and it's going to float to the top. So it's going to create a flock, and that flock floats. It does work with emulsifications if you reduce the pH. Emulsification agents are things like detergents, degreaser solvents. Mechanical agitation will also can also lead to emulsifications. And again, that's just really small droplets that are more difficult to separate from the waste stream. This is a DAF and industrial laundry. It has a mixed tank. So in the mixed tank, first thing you do, since industrial laundry, they're using detergents. They do a lot of oily rags, so that's the source of these oils. First thing they do is they drop the pH down to between 2 and 3, and that breaks the emulsifications. They add a polymer, and then they add a flocculant. And so this is, you know, from a inspection perspective, you can look at this and you can see here in the flocculant addition, you can see the flock forming. Hey, that's a good thing. You know, if you don't see any flock forming after the last step, that's not such a good thing. All right, so once you get flock formed, it then goes into a float tank, which is essentially is a clarifier. The oil that goes to the top is called froth. It is skimmed off continuously, so you're continuously removing it. And then the water portion goes over a weir and then exit here. You do have sludge form, so not everything floats to the top, so sludge will go down to the bottom. And these are also designed to collect sludge continuously off the bottom as well. So the two waste products from a DAF unit is froth at the top, sludge at the bottom that you have to deal with. So I've had absolutely no questions so far, and so can somebody just say hey, because I'm feeling very lonely here by myself in my room and just talking to others. Okay, good, thank you.
Yeah,
I was starting to wonder if the apocalypse finally happened or what.
No, we're here. We are listening. It's a really great presentation so far. I haven't had any questions in the Q&A box, but folks, if you do have any questions for Dan, go ahead and post them. But otherwise, I'll let you continue.
Thank you for the acknowledgement. All right, dissolved flotation. So this is one of our dairy processors, and they use it for milk fat separation. What's a little bit different from this one than what you just saw in the launderer is where the chemicals are introduced. In the previous slide, there was a mixed tank. Another way you can do this is you actually have a pipe. You introduce this into the pipe. And by doing that, introducing the pipe, you just have a greater contact with the different chemicals. And then as you can see, here's the float tank. Again, it's like a clarifier. Milk fat's coming up top. These provide a loading advantage over grease removal devices. You know, one of the big failures I've seen with industrial food production is installing gravity interceptors for grease. And the problem with the gravity grease interceptor in a large food manufacturer is they produce more grease and solids than what a gravity grease interceptor can maintain. So essentially, you can't pump them out enough to prevent grease and solids accumulating so that they eventually pass through a gravity grease interceptor. And so, you know, over time, we've had to require upgrades from these large facilities that initially installed gravity GRDs and haven't put in something like a DAF unit. And those have been successful. That stopped the oil and grease issues that were occurring downstream.
We do have a question for you, Dan.
Thank you.
Yeah, someone's wants to know that if a DAF went offline, would there be enough fog getting to the POTW to cause interference? And what would that look like at the POTW?
So typically, yeah. So I'd say there's a couple issues there. So if the DAF goes offline, you know, I've worked mostly at really large POTWs, and so I have not experienced oil and grease as an issue at the POTW itself as far as the treatment facility, but definitely it's a collection system issue. So you know, if it's not properly treated, it is in the sewer pipes right outside the outfall. It collects there, as well as causing problems from the next couple of pump stations. You know, the other problem is if they take it offline, essentially that's bypass, and that's prohibited. So you can't, you can only take a treatment system offline and cause bypass if they've notified you and if it's for required maintenance. And they still have to, and if it's going to cause issues, and if it's going to cause a permit violation or violation of effluent standards, and an accumulation of fog in the collection system certainly would qualify for that, then that is an illegal bypass. So they really can't take it offline unless they've got some other type of system that they're going to use temporarily to meet the standards. But certainly, if it's a large producer and they're not treating fats, oils, and grease, it's going to cause a problem in the collection system.
Thanks, Dan.
And another thing is you can rent DAF units. So, you know, if they had to do major work on a DAF unit, they could rent a DAF unit and bring a rental in.
We have two other questions specifically about the dairy waste staff. The first one was about the tank for the milk fat. They're asking what size. They're asking about the size of that tank. And then the second question related to the dairy waste staff was if pH adjustment is necessary before flocculation for that specific waste stream.
So so if you get into specifics about these different ones, I'm probably the wrong person to ask. I'm a manager and I just talk a lot. Yeah, I've been out to that facility and looked at it, but I really couldn't give you the specifics. But I will tell you, pH adjustment does occur. I don't know if they're doing that to break emulsions or not, or if they just need to do a pH adjustment to get it within spec, because they have, again, since it's a beverage manufacturer, they do have caustic and acidic rinses. The other one is I couldn't tell you what the size is, and that's going to vary depending on the size of the dairy, obviously, or the dairy processor. This is Dairy Gold, and it's a very large processor. It's one of our larger discharges, so it's, you know, I'm sure its pipes are in the 10,000, you know, several 10,000 gallon type of range of, I'm sorry, not pipes, but tanks. But you know, if you want to reach out to me, I can get you in contact with their permit manager who can provide all those details.
Great, thank you, Dan.
Certainly. All right, oil water separator. So free oil, where is it stored at? Again, kind of those, where's it going? Where does it manifest? Oily sludge. So that's the stuff that's on the bottom. That typically has to be removed. So what's the frequency of removal? What's its destination? And again, what were the documents showing, you know, the frequency and the destination? You know, you can also, if it's possible, you can visually inspect the effluent pipe for oil accumulation. If you're seeing a lot of accumulation there, then it's potentially an issue. DAF units. Okay, so in DAF, you're basically, you know, you're de-emulsifying, or you're bringing these chemicals, these oil droplets together. So, you know, how do you determine how much chemistry you need to use to get good treatability? Yeah, they could be using like jar tests is a common thing to do. If they are, well, do you have treatability records? You know, how do you know? Do you record what you know, obviously if you're deciding how much chemicals to add, do you write that down? Can you show those to me? You know, if they are adding acid to break up emulsification, what's the target pH? And again, frost sludge disposal, same old disposal stuff. And again, inspect the float tank. Do you actually see froth formation? I was at a centralized waste treater that was causing some issues, and you know, looked at their DAF unit. It was like a Soviet era DAF unit that they got off of Craigslist or something. But you know, I looked at it. There was no flock forming at it, and when I looked at the float tank, there was nothing on the surface of the float tank, which kind of you'd think, you know, if it's supposed to float things, that doesn't seem to work. And so that was an obvious issue there. Terminology. The only thing I want to talk about for terminology is you'll hear the term soluble oil. You know, there's no such thing as a soluble oil. Soluble oil is a highly emulsified oil. And a lot of times this highly emulsified oil, it's basically used for machining work. Needs a special type of treatment. It's still an acid cracking, but a DAF unit may not work on these. So a lot of times a facility will employ a tank, and it's typically a heated tank, and it's called acid cracking. So they drop the pH between 2 and 4, add some heat, and it breaks out oil emulsification. So typically, if you have something that's just highly emulsified, that might be your only solution. And it's kind of a batch discharge that you would do with this really unique waste stream. All right, pH treatment. How are we doing on time?
Let's see.
All right, I think we can make it through.
Yeah.
Okay, so pH, probably the most common type of treatment used in industries. These are the different types of ones that you'll find it at. It's used a lot, you know, in food and beverage. You have clean in place systems, which are doing caustic and acid washes, which we've discussed a lot already. Can happen as a batch. Excuse me. That's a truck wash using phosphoric acid to brighten up the metals, cause some issues. They were able to put in just a batch treatment tank, holds the washes. They have a caustic feed pump, pH meter, feed it in. It's pretty tough to mess up. But my experience is, yeah, it's pretty tough to mess up, but after 20 years of doing this, there's somebody somewhere is going to find a way to mess it up. Continuous treatment. All right, so here's the one. This is a food produce processor. They had pH. We required them to install this system a few years ago. So we have effluent coming in. It's highly screened effluent because they have all these produce particles, which can cause issues with the probes. The pH probe actually is on the influent line further upstream here. So this basically controls the chemical needs a lot. So basically the effluent coming in comes to this tank and it continuously recirculates. So that allows for mixing. There's 2 valves over here that allow for discharge. There's a pH probe that controls those valves down here. So once it's within spec, then one valve closes, which cuts off the recirc. Another valve opens, which allows the discharge. And then it discharges down this line. And here's the compliance pH probes, a lot of probes that you're dealing with. In my experience, there's a lot of different ways you can do continuous treatment and configure these things. It's just almost infinite. But people that do this, or the industries that do this, seem to be the ones that are able to stay in compliance. This seems to be, you know, as far as my experience goes, the most optimal way to arrange this type of system. All right, so, you know, if they're conducting neutralization, they have neutralization chemicals such as caustic, such as sulfuric acid or hydrochloric acid. So look for chemical storage, check continuous pH monitoring records. So Portland self-monitoring records, if they're doing continuous, they report daily highs and lows on their self-monitor report. You know, they may have thousands of pH readings, and we're trusting them to give us their high and low. So when you do an inspection, make sure you actually look at their records. You don't have to look at all of them. You know, I say, give me this date range, and do a quick scan and make sure that they are reporting accurately and that they're not reporting violations. What are the pH specs for discharge? So, you know, our limit is 5.0 to 11.5. What do they set their pH specs to discharge at? Hopefully it's not 5.0 to 11.5. That's kind of living on the edge. Make sure they have probe calibration and maintenance logs, check calibration standards for expiration dates. Does their meter calculate slope? See how you record slope. Slope is used to determine pH probe failures. You know, if you're not looking at those, then that's kind of a precursor of letting you know when your pH probe needs to be replaced. I had an inspector do this once. I was so impressed. He asked the person, hey, show me how you calibrate probes. So he made the person actually show that he could calibrate a probe. And what kind of controls do you have for preventing out of spec discharges? Dissolved metals, chemical precipitation concept is, you know, dissolved metals, if you raise the pH, they go into an insoluble form, and then you add coagulants and flocculants to form a floc so that they settle out. Wide range of applicability. Here's the solubility curve. Okay, so talk about this. So solubility decreases going down. If you notice pH, as we increase pH, all these metals start to drop down. You'll also notice that not all metals reach optimum solubility at the same pH, so that changes. And you should also notice as you start, let's see, this is copper. You know, once we get past 9 a little bit, it's going to start to become less and less soluble. Okay, so it is, you know, the optimum pH depends on the type of metal that you're using. All right, so here's a chemical precipitation at an Dyson job shop, essentially mixed tank. Chemical precipitation occurs first. You got metal ion, you increase the pH. Metal hydroxides are insoluble, but they're also really small. It's like a pin floc, so they're not going to settle very well. So you then need to add some type of chemical addition to make flocculants. So you coagulate it, create a flocculant, and then you send it to a clarifier, which again provides time for it to settle. The floc settles. See a little cone bottom tank, sludge comes down here, sludge is then popped to a dewatering process. Inspection tips, well, you know, what is the desired pH for chemical precipitation? Do they know that? How is treatment chemistry determined? Again, you're adding certain levels of flocculants and coagulants. How do you know how much to add? What's that based on? If I use any of the exception metals below, and these are the exception metals, first off, molybdenum. Molybdenum does not treat through typical metal precipitation, requires a specialized treatment. If they have hexavalent chromium, before they can take that through precipitation, they need to reduce it to trivalent, and then it will follow this. A big issue, especially in electrolysis plating, is chelated or complex metals. So basically, to do electrolysis plating, you're not using electricity to plate these, you're actually using a chemical. And this chemical bonds to these metals and doesn't allow them to come out of solution following a typical chemical precipitation treatment. And so they need to have they need to separate it and treat it in a specialized way. Does sludge go to the holding tank prior to watering? If so, you know, if it goes to a holding tank, the supernatant is a liquid that's above it. The sludge is going to settle down. That supernatant, what do you do with it? Should go back for pretreatment. Oh gosh, evaporation. Okay, so applicability. I've only seen it in, oh no, I'm sorry. I have seen it discharged in CIUs, and back in Jacksonville, Florida, where I first worked, there was one facility that did some precious metals recovery with it as well. I've never seen more evaporation occur than I have since I came to Pacific Northwest. A lot of it is just energy so much cheaper than it is in other places. So it's widely spread for non-discharge in CIUs. Inspection tips, look for potential discharge points. What we started doing now is asking what is the evaporator capacity, what is the evaporator rate. Let's say the evaporator capacity is 100 gallons and it can, over 24 hours, evaporate 100 gallons, but they generate 500 gallons of wastewater a day. There's a problem here. And so next question you can ask this, and this is a real life question. Show me how you operate this. One of our inspectors did that because he wasn't real sure that the thing worked. The guy had no idea how to turn on the evaporator. It probably hadn't worked for years. And again, now we're going into has waste. Have the solids been RCRA characterized, which means do they meet the has waste requirements? And again, all the different solids questions that you would ask. Organics treatments. All right, wide range of compounds, treatment technologies, volatiles, semi-volatiles, organic chemicals, BOD. Bob's going to talk about BOD after this, so I'm just going to gloss over it, which I was going to do anyway, but I'll go ahead and blame it on Bob. Applicability, groundwater remediation. If you have any organic chemical plastic manufacturers, and they're a little redundancy, OCPFS manufacturers could use this technology. Pulp and paper has a lot of BOD, so they may use it, obviously, industrial food processors. Let's talk about activated carbon filtration first. This is typically a polishing step. Carbon has a lot of porous sites on it, and organic chemicals will adhere to those, so they would absorb to those. Okay, so it's often a polishing step. Here's another blue tank, and it's full of granulate activated carbon that goes in here. You could also have powder activated carbon. Powder activated carbon is much finer, so it has a greater surface area. Usually you won't find it in tanks. What they could do is to do like a batch treatment. So let's say that you have just a tank and you want to polish some organics out of it. You could actually introduce the powdered activated carbon on top. It goes down to the bottom and settles, and then you collect it from the bottom along with the sludge. So that's kind of one way that you'll see that used. Inspection tips. How do you know when the carbon is spent? Again, you're taking up surface area on the carbon with these pollutants. After a while, all that surface area is taken up, so it's now spent. How do you know when it's spent? Because once it becomes spent, pollutants just pass through it. And they'll call that, the terminology for that is called breakthrough. What's the carbon replacement frequency? What do you do with the spent carbon? Where does it go? It can be reactivated. So some places can't take it and reactivate it. All right, air stripping. So contaminated water, basically, okay, so we've got this gizmo over here. This gizmo is full of these plastic packing materials. It increases contact time. You're going to introduce wastewater. It's typically, it's going to be it's for volatiles. And you're going to bubble air in there. And so the air goes through the water and it actually strips away any volatiles, and volatiles would come up through the top here. And again, where I've seen this used exclusively is for groundwater remediation applications. All right, inspection tips. How do you maintain proper airflow? If there's a lot of other gunk in the water, that packing material can start to foul. And then how are the volatile organics treated before they're dispersed in the air? You're introducing volatile organics into the air. That could be an issue. The ways that they are treated, two different ways. Through thermal oxidation, essentially you just burn them, and volatile organics are converted to carbon dioxide and water, or they can go through carbon filtration as well. Biological treatment, again, Bob's going to this stuff. Essentially, you're going to maintain an environment, optimizes bacterial degradation of waste streams. This is an aerated pond at a really large organic chemical manufacturer in Jacksonville, Florida. Biological treatment. It's amazing how bacteria can adapt to a wide range of organic compounds, just not what we typically think as BOD. They can adapt and they will treat for semi-volatile organics, benzene, xylene. They can be in aerobic, anaerobic environments. This is the type of treatment we use at municipalities. Municipalities, the bacteria get all the nutrients they need from what we flush or drain down from homes. May not be the case at an industry. So sometimes they'll need to add nutrients such as nitrogen or phosphorus. So that may be a need there. It is a heavy solids generation that produces a lot of solids, which are all those bacterial bodies, and can be a high capital and operational expense. This is a transportation equipment cleaning facility. Had a lot of issues with solids. This is a dairy. This is Alpen Dairy. They basically use a moving bed bioreactor, and what that means, it has these plastic carriers that are suspended in here. Biofilm collects on this, and this is where your biology is that's breaking down the BOD. This is at PDX. So for de-icing, they use glycols. Glycols have a lot of BOD. They're very biodegradable. So they use an anaerobic digester at the airport to treat for the ethylene glycol. All right, inspection tips, process control tips. So what do they use? They have to take care of this living environment. So how do they maintain this living environment? It takes a lot of work to do that. So what process control tests are used? Whatever they have, they should be documenting those tests or reviewing the operational logs. How do you determine when to waste sludge and how is sludge dewatered? And now going into sludge dewater and last type of technology, First off, cone bottom tanks. A lot of places will send it to a cone bottom tank. The sludge settles here. You have a supernatant. Draw the sludge off the bottom. Supernatant should go back to treatment. And then the sludge from the bottom then is going to go to some other type of treatment. Typically, there'll have to be some type of conditioning that occurs. So here, they're adding diatomaceous earth and feeding a slurry of the sludge and diatomaceous earth to this vacuum drum. So this is a drum, it's a vacuum drum. So it creates a vacuum, it has pores, and it brings that sludge, adheres that sludge and diatomaceous earth slurry to the drum, pulls the water portion into the drum, and then as the drum rotates, it scrapes into this little hopper here. Water again from this, the filtrate, that's the filtrate. The filtrate has to be returned to the head of treatment. Filter press again, sludge, a sludge slurry is filter membranes on each of these. The particulates adhere to the different membranes and gets dried, opens up, and goes into these little hoppers. You'll see these throughout DAF units, metal precipitation, biological treatment, all these can utilize some type of sludge conditioning. And the whole idea behind sludge conditioning is just to reduce hauling cost. If they are doing some type of conditioning, what substance are they using? Where does the filtrate go? It should go back to the head of treatment. Has it been characterized for recreatability? All the usual solid stuff. So, a lot of questions you can ask on any type of technology. You may not know the answer, and that's okay. What you're trying to say is if they know the answer. So don't feel intimidated. I don't know what the real answer is. You don't have to know what the real answer is. Let them answer it. Sometimes it'll be kind of obvious that they know what they're talking about. Sometimes you may not be so sure that they know what they're talking about it. And those are when you take notes and you go back and, after the inspection, you do some research on your own and see if what they said makes sense. So don't be intimidated by, I don't know the technology enough to ask specific questions. Ask the questions to get them to talk and just use your own judgment to be able to determine, do these people seem to know what they're talking about or not? And if they just go a lot, then that's kind of a pretty definitive answer there. All right, last slide. Permit required. What we started doing, okay, this will start at a metal finisher. Metal finisher was having some issues meeting their metal standards. We went out to them and we were just having a lot of issues. We went out, did an inspection, and this is what they told us. They told us they stopped using, they were still doing chemical precipitation, but they stopped using polymers. Polymers is because the polymers made sludge. And what they found out is if they stopped using polymers, they had less sludge production and were saving lots of money not hauling off sludge. And so we tried to explain, but that's where all the metals are that are causing problems because you didn't drop them out of a solution. So what we've done now is we make operation and maintenance plan a permit requirement. They have to give us treatment system schematics, treatment chemicals they use, maintenance schedule, O&M logs. If they make any changes to this, they have to submit those revisions to us. And that's it for me. Any questions?
Thanks, Dan. What a fantastic presentation. We do have a few questions. I think we do have time for it. So I'm going to throw some questions out for you. And while we are asking these questions for Dan, I'm going to go ahead and throw the poll up on our screen. So Dan, we'll go back to some of the earlier technologies. This one, it says, referring to visually inspecting effluent pipes for oil accumulation. For an in-floor separator, would the clean out be where you're inspecting or further down the line, perhaps in the manhole?
So it's going to be what, and again, that's going to vary depending on what you can see. Like the couple examples I had were above ground ones, so it was real obvious to see them. But certainly the clean out would work. The next manhole or the point of compliance itself would obviously work. So it's whatever's available given that industry's situation.
Okay. With grease interceptors and amalgam separators, do you guys confirm the proper installation and confirm proper operation of these units? Or just do you just, it says, do you ultimately just concern yourself with compliance or non-compliance?
Yeah, so somebody had said this, maybe a couple of people said it last week, essentially, we kind of understand how treatment systems work, but we're not engineers. So it is incumbent upon the industry to get it right. And even if we were engineers, to be able to get it right depends on the waste streams. And you have to really understand the waste stream. So you really can never get involved to do it. So the answer is, yeah, it's on the compliance end of it. I mean, certainly if there's something that's just so obviously stupid that they've done, we would get on top of that. But most of the times it's just not real obvious. It's like, okay, this looks like a reasonable way that it can happen. And it may not be a reasonable way given specific characteristics of their waste streams, but you're never going to be able to have the knowledge. And again, somebody else has said this is a common answer. Hey, once you get that depth into it, and if it still messes up, you kind of own it. You did what they said. So typically if it's obviously bad, we'll say something, but compliance, in the end of the day, it's compliance determines whether it works or not.
Okay, great. Well, we're running out of time, so I'm just going to, there are a lot of great questions. There's a lot of good feedback on here, Dan, saying that your presentation was really informative and a lot of folks are thanking you. But we'll wrap it up with one final question. Let's see, where did it go? Yeah, someone's wondering if you guys have any juice processors in Portland or if you've run into any, let's see, juice processing facilities, and if so, what kind of technology do they use to remove the pulp?
So we do have food. So we have several fruit and vegetable processors. So essentially, they're coming in and they're cutting up fruit and vegetables. They're not producing a juice as a product, but juice does get produced as a waste product. And so they use a lot of, a lot of different screens, screen baskets, a rotating screen, just a lot of screen technology. And usually it's in series. So they start out with larger screens and then work it down to smaller screens. It's really important because all these facilities also have to maintain the pH. And those solids, fruit solids and vegetable solids, can get onto probes and cause interference with the probe as well. So it's not actually working. So it's really imperative that they remove those just to be able to properly measure their pH. But the answer is a lot of screens.
Do you guys have a template for the pretreatment maintenance plan that you require in the permit?
So we do have it's in our permit, it's in our special conditions. So if you want to reach out, Bree Hulse is our permit writer, and she is presenting on Oregon Oils on Thursday. And so if you want to reach out to her, she can get you a copy of our permit language.
Okay, yeah, I'll get them connected. First, yeah, okay, well, great. Thank you so much, Dan, for joining us today. With that, we will go ahead and close out our second poll. We've done 2 polls so far, folks, so if you haven't seen them on your screen, do let us know. We are going to try to start reading the poll questions out loud. I did miss the first poll. We're trying to dial this in, so thanks for your patience. The second poll question read, carbon filtration using granular activated carbon is an effective technology in treating which type of pollutants? And we show that most of you guys answered with organics. We have 9% BOD, 4% answering fog, and 12% answered suspended solids. So Dan, did you want to chime in there before we move over to Bob's
Yes,
presentation?
correct answer would be, yes, organics would be the correct answer.
Great.
Fog and suspended solids would cause a clogging of it, and they don't really adhere to the surface of the carbon. They just clog it all up.
Sure. Okay. All righty. Thanks, Dan. Hey, Bob, are you still with us today?
Yes, I was muted, but I am with you.
Great. Well, welcome. We're going to go ahead and ask you to share your screen with us.
Alrighty.
I am getting him dialed in here right now.
Sorry.
Oh, did I get him?
Let me let's see. Oh, you know what? I might have to close the poll. I apologize, guys.
Oh, there we go.
Alrighty.
Okay, yeah. We
There
can
we go.
see your screen,
Is that it?
Bob.
Hey.
That's it. Okay, well, welcome. We'll hand the reins over to you.
Thank you very much. I have to say, that phrase, are you with us? There's a meme floating around that I think is really hilarious. It sounds like you're at a seance. Bob, are you with us? So my name's Bob Smith. I work with a group called Cambrian, and I've been about 20 years now in decentralized wastewater, working for a number of manufacturers that serve different industries. And I really appreciate Dan's presentation. It was a great compliment. As I was putting together my slide deck, I kept wanting to dive into technologies, and that wasn't my overall goal. So really, the two presentations I'm hoping are somewhat complementary. I'm doing more of a deep dive into BOD and then different food and beverage applications. And I come at it from a little bit of an education standpoint. I know that's a little bit of a sticky wicket, like Dan mentioned at the end of his presentation, getting into the operation of equipment and instructing people on what to do gets to be really challenging, especially on the regulatory side of things. Very similar in the challenges in the manufacturing side of things as well. I mean, obviously with our own equipment, but with other equipment that highly affects any downstream process, we have similar issues, and education is something that I end up doing a great deal of. And there's not a lot of easy, accessible resources for folks in industry to be learning these things. So I'll apologize slightly in advance. Some of the stuff is going to be very basic to some of you. It might be useful for some of you who might be somewhat new to the industry. But I come at this from a sort of an educational standpoint, because we all have to interface with folks in industry that have widely varying levels of expertise in wastewater. And even though they may have wastewater knowledge specific to their facility, understanding how that fits into the greater context of the wastewater industry and the effect on the POTW downstream, even the conveyance lines and lift stations in between the industry and the POTW, that context is often missing as well. I've also walked into facilities and basically told their management what they were paying in, say, surcharges, and had people tell me, no, that can't be correct. And how did you get that information anyway? Not understanding that it's a matter of public record, and we can research these things and find them, but not even knowing what they're paying, what they're discharging, and what that whole situation is. So the level of knowledge varies widely. You'll find some folks who are extremely knowledgeable, but in my experience, many times not so much. Long-winded apology. Let's see if I can make this slide go forward. There we go. So I figure it's worth the start, and talking about what wastewater is going to come up a little bit in the future here. So I'll just start talking about water that is affected by human activity. And it's only wastewater by definition. Something that is really, really big, and the topic that I wanted to bring up because for this slide is we're seeing a lot of interest in reuse, have been seeing a lot of interest over the past couple of decades in reuse. But I'm seeing some things now in other areas that are really facilitating some real serious discussions. El Paso, Texas, for instance, is going to be implementing actual BOD limits on their industries. And part of the reason is that they have some of the largest, most sophisticated water reclamation facilities that they operate. And having an industrial discharger that can throw that out of whack is a big deal. They're also coming to capacity on some of their facilities. So we're entering sort of a new realm in terms of being able to control industrial dischargers, and understanding what some of those issues are will help all of us. They're talking, with BODs, we're really talking about huge, wide-ranging differences from both municipal scale sewage as well as day-to-day fluctuations in the facility itself.
Hey, Bob.
So,
Bob,
yeah.
Real quick, your presentation notes are also being shared in with your screen. If you could.
Oh, absolutely. Let me
Great,
see. I have the. I was actually. Interesting. Is there a way to share a different screen?
Usually there's the option to put it in presentation mode. Let's see.
Right, I'm presenting
Maybe
on another
display
screen.
under
That's the
display
thing.
settings. Oh,
Okay.
I see. Could you pull over?
There we go.
There you go.
How's
Yep.
that?
Full screen. We got it. Thanks, Bob.
Very good. No problem. I'm working off a 2-screen workstation.
Gotcha, no
So
problem.
when we talk about treatment, and Dan mentioned this as well, in municipal wastewater, a lot of times the biological component that we're going to talk about with BOD in particular is what everybody's thought goes to when you talk about wastewater treatment. And luckily, Dan's presentation, again, fantastic, illustrated many of the other technologies that we're going to come across in industrial wastewater. Everything from the metals removal all the way through fats, oils, and grease, DAFs, and tertiary treatment. A lot of folks in industry right now are talking about getting to the point where they can create reuse water and feed their cooling towers and stuff like that. So in designing what treatment is, you really have to be really pretty granular, and it depends on what the industry is. Lots of variation even within the food and beverage industry, and what I'll point out too along the way, lots of variation within what we might consider a single vertical, something like dairy, just being used as an overall term. Not really definitive enough. There's a lot of facilities that would technically fall under the umbrella of dairy, for instance. So identifying what constituents are being put in the wastewater that needs to be taken out, and then identifying what your needs are, whether that's removing enough fog to keep from plugging up a pipe or a lift station, keep from blowing up a lift station, to creating water that's appropriate for reuse quality. Even have worked with folks that, and I know a number of folks here are going to be familiar with folks in Salem who brew beer with reuse water. So, and like Dan, with COVID, I have not spent a lot of time speaking in the past 6 months, so my apologies there. So appropriate use for reuse, that's going to become a much bigger and bigger and bigger issue that industry is going to have to deal with, and conversely, we are going to have to deal with as well. Dealing with a complex treatment system, whether you're going from really simple applications in a lot of food and beverage processing facilities historically. Land application is one of those technologies, and it's a very simple, seasonally appropriate, and you basically will spray the water out onto a chunk of property. As property values and suburban encroachment begin to occur, that applicability of having a large lagoon and a large amount of acreage is also becoming a restriction for some facilities. So there's a number of things that are sort of driving the industry and changing things for food and beverage processors, and BOD was one of those. It's also starting to be regulated as an agronomic limit. So hasn't been done a whole lot up until now, but now folks are starting to look at that from a permitting level on how much BOD you can apply to a certain number of acres per day, as an example. Hasn't been as well regulated up until now, but it's becoming more and more of an issue, as well as TDS. But we're not going to talk about that stuff, about that specifically right now. So why treat wastewater? In industrial pretreatment, we're really looking to reduce the load on the POTW. Surcharges, looking at reuse, lots of effects directly for industry. Overall, though, in trying to deal and explain with folks, talking about the effects on the POTW, that's where I think there is a little bit of room for some education. And I think it really helps folks to understand, just what downstream processes they affect as a facility. And it's the levels of effect can be reasonably felt. I do know of some folks, and I'll try and be really generic, but say a particular brewery that can affect the operation at the POTW if they make a mistake, more or less. It can actually have a direct and almost immediate effect on the treatment plant for the entire community. So I think there's more and more folks that are becoming aware. Obviously, for all of us on this call, we're quite aware. That's what the function of the industrial pretreatment groups are. But I think in general with industry, again, coming at it from an education standpoint, being able to talk about, hey, what you're doing is going to affect everything downstream is worthwhile to talk about. In that vein, biochemical oxygen demand, a little bit of history that is mostly gone now. Used to be biological oxygen demand. It is the available dissolved organics or particulate organics, okay, that are in the wastewater that will create an oxygen demand on a receiving water body. So if you put food into a receiving water body, bugs and other aquatic organisms are going to try and consume it. And if that's done in an aerobic condition, then it will deplete the dissolved oxygen from the receiving water body, creating that oxygen demand. And that's how we measure organics in wastewater, and we refer to it as biochemical oxygen demand. One thing that has started to happen now as well, especially with manufacturers and wastewater treatment, is in looking at different oxygen demands and indeed splitting up biochemical oxygen demand into its other constituents. So particulate versus soluble, for instance. Particulate BOD, can be removed by filtration. A lot of times actually involves being a particle of some sort that would exert an oxygen demand in an environment, but maybe can be pulled out physically. Levels of degradability you're starting to see in literature, whether it's difficult to degrade or easy to degrade. And a lot of food and beverage wastewater is rather biologically available and easy to degrade, with the exception of fats, oils, and greases that are very stable in the environment and can exert an extremely large amount of BOD, soluble BOD, if the molecules of fat are broken. And so emulsification, as Dan mentioned in the previous presentation and did a wonderful job with, is breaking up the particles of oil, say, into particles that are so small they don't coagulate on their own anymore. But if you actually break them and use pH to break the bonds, you end up with salts and glycol, things like that. And those end up generating a soluble BOD. So just like the story Dan told, which was fantastic, about, oh, well, we were generating solids, so we stopped putting the chemical in that was helping them flocculate out their metals. If you put some chemicals into a waste stream that has, say, a high fats, oils, and grease to try and get it to go down the drain well, you're just pushing all of that material, that BOD, that extremely high load, down to the next stage, either in their own treatment plant or at the POTW. There are other oxygen demands as well, not really within the scope of a 45-minute presentation this morning, but nitrogenous versus carbonaceous, big deal for wastewater generators that treat sewage, right? Nitrogen issues, phosphorus, nutrient issues, those types of things. Those all exert oxygen demands as well. They also are necessary nutrients, however, to drive the process for biologically digesting the carbonaceous materials in BOD. So as Dan mentioned, you might have to add some nutrient to a industrial discharger, food and beverage discharger, to facilitate these biochemical reactions. Think of it like adding the NPK ratio to, say, a compost pile. 100 parts carbon to smaller parts of nitrogen and phosphorus. And that similar ratio is often necessary to get the maximum amount of biological digestion on the carbonaceous material. From an entire wastewater treatment perspective, you are looking at a whole bunch of different parameters. Okay, I'm going to focus on BOD, but just so we acknowledge that there's a whole bunch of others out there. Some of these are going to be appropriate to certain facilities, some not so much. Okay, but there's a whole laundry list of things that we would take into consideration in working with an industrial discharger. BOD ends up being one of the biggies, one of the heavy hitters, along with flow. Fats, oils, and grease is another one. There are a few interrelated characteristics like fats, oils, and grease. Break those molecules up, they become BOD, sort of that kind of a thing. But I'm just going to focus mainly on the carbonaceous substrates in BOD. Also, if there are any questions, you won't derail me, so feel free to blast them out at me during the presentation. But I'll keep going. I'll just keep rolling. So someone just interrupt me. One of the components that I find is surprisingly not ignored, but just not considered all the time. Again, it's going to be something that everybody on this call is going to be super familiar with, but in industry, not so much, is the concept of total load of BOD. Everybody in the industry looks at concentration, milligrams per liter, and it is a slightly more advanced concept, I guess, to look at total load, where you need the concentration and the hydraulic load, and be able to measure the amount of BOD in terms of pounds, in terms of total mass. And that idea gives you, that concept gives you more of an idea on what your plant is producing and what you have to do to remediate it. And I find that this concept in the folks I've talked to, not often really well understood. So they're talking about, okay, it often boils down to a concentration, trying to get down to a certain pH in their effluent, to a certain concentration in their effluent, but looking at in terms of pounds, that's a little bit foreign. So again, here's an educational opportunity for folks that isn't technology dependent, not operation dependent, but it can get more context for folks in these industrial discharge situations. So what is waste stream? A raw sewage, which is something that most folks have like an intuitive sense of. They have some experience with it. Okay, so comparing their discharge to sewage is often the comparison that you hear. Okay, that's what they have available to them in context. So milligrams per liter is the most common unit. Also corresponds to parts per million. That's fading away. Hopefully we'll all end up in metric someday. But it's a very small quantity that we're used to hearing. Okay, so the old Ivory soap commercial, 99.44% pure, so pure it floats. All right, that was the commercial and the marketing when I was a little kid. 99.44 is actually quite close to the accepted values for brewery wastewater. We're looking at 5,000 BOD, that kind of a thing. Raw sewage is far, far cleaner than that. So when we're talking about something 99.5% pure, 99.4% water, you're looking at something that is many, many times nastier than raw sewage. Kind of an interesting thought. Yeah.
Hey, Bob, a real quick question. What is the best pre-treatment for BOD?
No way to answer that. It's going to depend on facility. and it's going to depend on the type of BOD and what the source is. There are many ways to pre-treat and help reduce BOD. And in fact, so since we've just gotten a primer on DAF, it was excellent. DAF, for instance, can reduce, say, a milk bottling plant's wastewater, say between 40, 50, 60% in terms of their BOD load. Just breaking the milk emulsion and floating out the soluble components using a DAF. So you can get significant BOD removal from some of the pretreatment technologies for sure, but it's going to be so highly dependent on the actual facility itself and what product they produce. Someone else mentioned juice. Do have some experience with, say, juice plants, filtration to get the particles out, the larger particles. Absolutely exactly what Dan said. The soluble component that's left, imagine that as like sugar water. Okay, that doesn't respond to filtration, doesn't really respond to coagulation either. So you're looking at, say, sugar water, that can exert a large BOD, and the pretreatment technologies aren't really going to affect that. You're really looking at biological only. If that answers the question. I hope so.
Great, thank you.
So you municipal waste strengths, we're looking at a BOD, say 250 to 400 milligrams per liter, somewhere in that range. Typical sewage from residential sources, what everybody thinks of in terms of raw sewage. Okay, it's a little bit grossed out. What is high strength waste in the food and beverage industry? All right, there are some actual things in regulations, some rules that actually define high strength wastes. Generally, from my research, they are just called higher than typical municipal wastewater. Okay, but how much higher is kind of the deal? Okay, how high can BODs go in a facility? Okay, 1,000 BOD, 3, 4 times, 5 times as much as municipal. Is that high strength? 5,000, 10,000. Okay, I've seen numbers on paper, lab reports, and things as high as 30. 40,000 milligrams per liter. So where do you put that if you're trying to categorize? Okay. As far as this, again, this is everybody. This is the wheelhouse for everybody on this call. Not necessarily though in industry. So how do you regulate that? Is it a concentration limit like they're doing in El Paso now? Is it a total load limit, which would probably be the most fair in some sense, but it's going to be a little more work to get that granularity. Categories for concentration, having moderate high waste strength, a little higher strength waste, and then like ultra high strength waste or something like that. In those types of scales that I've seen, which work really well for putting together a program and simplifying it, the high category or the super high category has simply not been high enough. And so you really disincentivize everything, because once you reach a certain level, then you dump everything. And understanding that even say in a brewery, certain side streams are going to be extremely high, 20, 25,000 milligrams per liter, while the overall flow may very well be in the 3,000 to 5,000 range in aggregate with everything mixed. So defining that BOD level, what is high strength, and then how does that interface with your pretreatment program? Really an interesting triumvirate to really get your head wrapped around. And then so what? So why do we do this? And these are the things that I've heard personally. I'm sure you guys have heard many, many others. And in fact, it might be worthwhile to compile all of them. It's just a little sugar water. I've been told it's completely organic. Okay. Fantastic, it absolutely is. It isn't sewage. Okay? This just ends up as food for animals. This is, it's all fine. There's no problem here. Nothing to see here. Why do I have to worry about this stuff? And we'll go through some more specifics now. So I'd like to dive in a little bit, because even though we look at each one of these as individual, say, verticals in the industry, there's a tremendous amount of variation even inside of each one of these verticals. So brewery wastewater, this has been the topic of pretreatment folks now for the past, say, 10 years. It comes up at every conference. looking at brewery wastewater, and the explosion really in terms of microbreweries and regional craft breweries has been neat from a beer drinker's perspective, which is fine. But on the other hand, from a wastewater perspective, it's been causing, people have been noticing. Folks have actually really been noticing. It's just a little rinse water. You know, you're just rinsing out the tanks from your brewing process. You know, so what's the big deal? Well, that rinse water contains dissolved sugars, a little bit of alcohol, obviously. Alcohol is very soluble, straight BOD. The particulates, okay, so now you've got yeast and trub. So this is another piece of it. Yeast and trub is basically the spent yeast, or the yeasts that have settled to the bottom of the primary fermenter, particles of hops and other adjuncts that are added. Spent grain is the chunks of malt, the larger particles that are part of the mashing process to get the sugars out. And they're the starch, source of the starch that gets converted to sugar. That is generally removed and then, say, fed to pigs or something like that, and hauled off as a solid waste. But there's a lot of the smaller solid material that is left in smaller breweries. It's just left in the waste stream and discharged. Very, very large breweries, they capture the yeast and reuse it, and have labs and stuff to keep track of all that. And it is in the microbrewer, regional brewery range where there might be some source segregation, some separation of that material, have that yeast go to somewhere else. Different technologies and tankage and different processes used to separate those things, but that yeast can be a really big part of the load. Some of the data sets that I've seen have shown the BOD of, say, a high yeast concentration waste being in the 25,000 milligram per liter range, which would drop the average BOD of the entire facility down into the 2,000 to 3,000 milligram per liter range instead of the 5,000 to 6,000 range. So these, individual side streams within a particular facility, can be part of the solution for a particular brewery. They put a little effort here, reduces the overall load on the other side of things. Conversely, talking about it in terms of, say, a program where there's a high limit at 3,000 milligrams per liter, they don't have a chance. They're never going to get below 3,000 anyway, so just dump it all. So got to kind of see how the overall effects that, and sometimes there's some unintended consequences of a program. Something that Dan mentioned in the previous presentation on flow equalization. Chemical processes in a brewery, you're often looking at caustics for burning out organics and cleaning tanks. You're looking at acids for getting an accumulation, a mineral accumulation called beer stone out of the tanks. Beer itself is on the acid side of the scale. So between CIP, clean in place operations in a facility, disinfecting operations within a facility, and then other types of cleaning operations, you're going to have an interesting mix of acid and base, maybe even caustic, all the way to caustic, and mixing as much of that as possible and getting self-buffering, just like Dan mentioned. Great way to start. That's going to be a big piece of the beginning. Doesn't really affect BOD directly in that sense, but it's going to set the stage for everything downstream to have a better controlled wastewater stream. Brewery wastewater, folks are getting more and more familiar with what breweries generate now. And Brewers Association publishes best management practices paper. However, BOD 600 to 5,000. From a design standpoint or a regulation standpoint, how useful is that range? And then side streams can be far, far higher, 25, 30,000 milligrams per liter. TSS, pH can fluctuate as well. Intermittent shock loadings, like I said, from CIPs and that kind of a thing. And so in context, if you're looking at something now, we all are familiar with, BOD 5,000 milligrams per liter. We see that as part of our daily lives. But to explain to someone that might be more than 10 times the waste strength of raw sewage, more than 10 times the treatment capacity and aeration capacity necessary to treat that to a secondary standard. Okay, that's something that I think we have an opportunity to educate in the industry without getting too much into the operations of things, without getting into the details, so to speak. But these types of things are actually missing, in my experience with the consulting community as well. A lot of folks that have come up and learned wastewater from the municipal wastewater design side underestimate a lot of times what folks in a brewery or a food manufacturing facility actually produce. And then breweries are often now both brewing and packaging, and a lot of folks are doing retail packaging. One of the characteristics in the beverage bottling industry, and I'll get into some of this in a little bit as well, are bad packaging runs. And if you've got a bad packaging run, they'll do something that's referred to in the industry as a can crush or a bottle crush. If it can't be sold, which sometimes you can and sell it, it's perfectly good product. It just, you know, is mispackaged or something like that. But if it was a bad run that they can't sell, then especially in the larger facilities, they'll crush the material, the liquid goes down a floor drain right into the system, and the rest of the stuff goes to the landfill or gets recycled. That can be an enormous spike in load as well. And without a treatment system in place, that just goes straight to the POTW. Beverage bottling, this is something that we have some experience with as well with some of the larger bottlers. There's wide ranges, just like in the brewing industry. There's some parallels amongst all of these verticals I'm going to talk about. And in beverage bottling, you see this with breweries as well as large soda bottlers. There's also smaller craft bottlers. And then all the way down to boutique, say kombucha bottlers and things like that, that is becoming very, very popular. You're looking at BODs from a large soda bottler being in the 3,000 to 7,000 milligram per liter range. But those unique events, can and bottle crush, can be absolutely enormous, 30, 40,000 milligrams per liter. Where the bulk of the wastewater load comes from, say, a Coca-Cola or Dr. Pepper bottling facility is when they do line changes, switch out all of the equipment to a different flavor, for instance, run a different syrup. And then in the rinsing and cleaning operations, you're getting basically sugar water rinsed directly down the drain. It's going to be low in nutrient. It's going to be extremely high in BOD. All right, pH is generally low. Acid plus sugar tastes really good. And so whether it's orange juice and you're looking at acid sugar that comes out of a fruit, or an engineered beverage, like one of my favorites, like Mountain Dew or something like that, you've got sugar and acid combined to make it taste good. And that's a characteristic of a lot of food and beverage products in general. So BOD loading can be 20 times or more municipal sewage, raw sewage. So that whole idea of, hey, this is just a little sugar water, it's not a big deal, okay? It can be an enormous load for a downstream system, especially in smaller communities where the POTW is relatively small relative to the size of the industrial facility. One of the beverage bottling facilities we have worked with in the past actually brought back half of the load capacity at the plant by installing a pretreatment system. This is actual data from that plant that I just mentioned, where the pretreatment system brought back half of the load capacity at the plant from a BOD pound standpoint. You can see on the left side of the graph, BODs ranged. You know, a couple of those spikes on the left-hand side of the graph actually peak out much, much higher than 10,000 milligrams per liter, okay? All the way down to certain points that are dropping down virtually to zero. And so the fluctuation in one individual facility taking daily samples, you see ranges that are absolutely unimaginable almost in terms of trying to deal with them, at least from a municipal plant perspective. You just don't see fluctuations on any order like this. Yet, this is what any type of pretreatment equipment has to be asked to do. So when looking at, I think Dan mentioned and did a really great primer on DAF. The efficacy of a DAF system, for instance, is highly predicated on the chemical cocktail mixture that goes in to the DAF at the beginning. And if you're seeing fluctuations of this magnitude in what's coming down the drain, very difficult to, even with a really good procedure, create a mix of coagulants and flocculants that are absolutely appropriate at every given point in time. This, I also will mention, these numbers come after EQ tank. So this is equalized flow going to the pretreatment unit. So that type of a fluctuation, really, really hard to deal with. And again, just bringing this into context for folks so that people in industry understand, what they're doing to the downstream processes. Super important, can't emphasize it enough. Fruit and vegetable processing, in a lot of agricultural regions, this is a big deal, but in the Pacific Northwest particularly so. A lot of different fruit and vegetable processing facilities. And where you see, like on the picture in the right, where you're just taking fruit, rinsing it off, getting it ready for retail sales or something like that, there's a surprising amount of BOD that's released into that rinse water. It'll get reused a number of times, and by the time it is ready for discharge, it will actually contain a fair amount of BOD. Whenever you have to break the cell wall, chopping, blanching broccoli in this case, in this picture, peeling potatoes, whatever it ends up being, if you break the cell structure of the plant, you're releasing a tremendous amount of BOD. And you can get those levels in the thousands again. Okay. However, in terms of generalizing vegetable processing, for instance, or fruit processing, there's a ton of different facilities out there doing a wide variety of products, everything from juice to retail packaging, bagging lettuce, making value-added products, that kind of thing. So it can be very, very difficult to generalize and categorize the biochemical oxygen demand coming from a particular facility. So just saying a juice manufacturer or just saying a fruit and vegetable processing facility, very and not very descriptive at all. It really does boil down to the individual facility being evaluated. And finding that data on a representative facility can be extraordinarily challenging. And so as long as we understand that, understanding from the regulatory side of things, you're really not able to, help them out with design and stuff like that. But just understanding that finding that exact data can be very challenging. That might be a place where connecting people in the industry together, hey, you're doing something similar, maybe they can talk. That may or may not be appropriate, may not happen. I've run into people who are very collegial with competitors, run into people who would not, let them step foot within a mile of their facility. So sharing information, I think, is a better way to go, but not everybody thinks that either. But if you're looking at everything from blanching, cooking, freezing, cutting, chopping, ingredients, making food ingredients for other processors and value added, huge wide range of constituents. And when you're getting to the finally prepared fruits and vegetable things, soups, snacks, chips, other packaged fruit items, FOG becomes a bigger issue again, changes the whole nature of the wastewater that's being generated. But in general, BODs through the roof, measured in the thousands, and can be a very big impact on downstream processes. This is an aerial photograph for just a vegetable packer in Oregon. They bag up frozen sweet corn and things like that. This picture was taken one summer before they were land applying, and the color is indicative of the process they were doing at the time. Seasonality for fruit and vegetable processing is probably the biggest issue that needs to be dealt with. Both the load and the flow will peak during whatever season of that fruit or vegetable that's being processed. In wineries, you're talking about crush season in the fall when the grapes are coming off the vines and going through the process to try and get them into fermentation. In this particular facility, it was sweet corn getting harvested and packaged and frozen, going from basically a few thousand gallons a day to over 1 million gallons a day over the span of a few weeks, with a corresponding increase in BOD from virtually zero to thousands of milligrams per liter. And it overwhelmed 80 million gallons of storage. Happened to rain, they couldn't land apply, filled up the whole valley with odor. These are some issues that are related to BOD and the magnitude that one particular facility can have on a region. Another one that pops up fairly often, meat processing. And in meat processing, a lot of times we're thinking about the abattoir, the slaughterhouse. That is one of the difficult ones. Many times these are located outside of cities, so you're not looking at an abattoir being probably downtown any longer, as they once were. But still, very difficult to generalize. Many different verticals within the meat processing industry. So you've got slaughterhouses and abattoirs, but further processing, taking the entire carcass and cutting it up for retail sale, freezing, and then value add products, again, food ingredients, and then making everything from, say, chicken nuggets to canned soup and all of the stuff that's in the frozen aisle at the grocery store. Many different aspects to meat processing, and they all have different wastewater constituents, different levels of BOD. One thing just to keep in mind, that when we are talking about things like blood, very accessible as far as biologically accessible, high level of solubility, very, very high BODs. Very similar to, say, sugar. Milk and dairy processing, again, another market vertical that has a lot of sub verticals. So if you're looking at a facility that bottles milk or retail fluid milk, you know, lots of different verticals, interesting pattern. All right, this is how a lot of the food industry is. Many different verticals, many different individual processes sort of lumped under individual umbrellas. And for our purposes as wastewater folks, really have to kind of look into it a little deeper. It can be difficult to generalize constituents. You've got fluid milk bottling where you've got, say, rinse water from milk vats. You've got milk, more or less, very dilute milk. Okay, and then some of those bottling facilities bottle other beverages like orange juice, in which case they're really more like a beverage bottler than they are, say, someone that makes, like Chobani, that makes yogurt. All right, and then there's a lot of value add processing, butter, ice cream, fats, oils, and grease becomes a bigger issue. Yogurt, cottage cheese, and cheese manufacture, you're now fermenting some of these milk products and generating acid in the wastewater itself. And then you've got dried milk powder and food ingredient manufacture, totally different process yet, where you're making dried milk. It, of course, is available for retail. Apologize for that. But it's also used in many other food ingredients. So again, understanding what that is, but in milk, fluid milk processing, you're looking at BODs that can range in the 500 to 1500 milligrams per liter, and breaking the milk emulsion and running it through a DAF can greatly reduce the BOD.
Hey, Bob, I've got a couple questions. I'm trying to stay ahead of the game here. So the first one is, would a rendering plant present the same issues as a meat processing plant?
That's one of the ones I didn't mention. So a rendering facility I would consider under meat processing. Obviously, they're dealing in fats, oils, and grease specifically. But in doing so, they generate a water-based soluble stream that is particularly nasty. And so it would be a major issue. They'll generate a wastewater that is going to be high in fats, oils, and grease because eventually machinery has to be cleaned. And the best way to clean oily machinery is to break it with caustic. You're basically creating soap. And so when you digest or break fat emulsions with caustic, you're creating soap. It breaks it up into a fatty acid and glycol, which is soluble in straight BOD. So it is a significant issue for sure. Not only is any liquid, like water liquid soluble material from the rendering byproducts, so to speak, part of that, any cleaning operation basically doesn't just emulsify, but you'll probably break some of those bonds and create more BOD just in the cleaning operation.
Okay, great. And then I'll get two more real quick. Considering BOD from a brewery, would it be suggested issuing a brewery a wastewater discharge permit if they only discharge about 1,000 gallons per day?
That's, that's the tough question. I want to see more and more breweries start up and get operating with as few hindrances as possible. If you are in a community where their discharge negatively affects your system, I think you have to consider it. But that's one where that's a tough one overall. 1,000 gallons a day seems like a small amount, but it could be a significant load in a small community's wastewater system. That's one that's not easy to generalize.
Yeah. And then another one, I think referencing the slide you currently have up, is what is a vertical?
Oh, sorry. Just like in wastewater, when we start throwing out BOD, TSS, and all that, we can confuse everybody else. I apologize. Market verticals, looking at a particular application, I guess is a better way to put it. So dairy processing, a lot of folks would consider dairy as an industry vertical. That is everything having to do with dairy products in that vertical. So all of these things would fall under that. My point is that there are sub-verticals, and so there's everything from this. And then you get into actually the dairy production, which involves manure management, a lot of digesters in that industry as well. So that's kind of what that means.
Great, thank you.
Sure. Oh, let's see where we at now. There we go. So real quick, something to think about, a little thought experiment. Okay, this is how I got through college. I know there's a brand name on there. I hope I don't get in trouble, but 1 can of this soda has about 46 grams of sugar. It's about 12 ounces of liquid. And if you imagine, and do the calculation, if you assume sugar is C6H12O6, that's an assumption. It's actually mostly corn syrup. If you spilled 1 12-ounce soda down the drain in a home that generates an average of 200 gallons per day, you've increased the load, the BOD load from that home by about 10%, just in 1 can of soda. And that soda product might be in the neighborhood of 100,000 milligrams per liter. So having this idea is understanding that sewage at 400 milligrams per liter are products that we eat and drink and have interaction with every day. We don't think of using the same units. And before I really dove in neck deep in this research, I didn't either. Very knowledgeable in wastewater by that point, rather knowledgeable in drinking Mountain Dew, and making the connection between the two. Okay, that there's the difference is 100,000 milligrams per liter versus 400. That was something I missed. So I think this idea that our everyday products and things involve really, really large numbers when we're looking at wastewater is worthwhile to convey and communicate. All right, and beers can be higher yet. I've heard of some folks doing some actually lab stuff to, because they got curious and have measured things like in the 120 milligrams per liter, that kind of a thing, between alcohol and lots of sugar, the big beers that can be made. So the processes, this is where I'm going to skate. We're getting a little low on time. Dan went over individual processes much better than I, but in general, physical, mechanical, biochemical, and chemical are the fundamental processes we talk about in terms of wastewater treatment. I'm going to focus a little bit on the biochemical. Dan did a great job with the physical, mechanical, and the chemical. One thing that is kind of interesting about the chemical is that the chemical is generally used to enhance physical, mechanical as well. So it's a piece that ends up finding its place in many, many different industrial treatment processes. Baths need it, settling can be enhanced by it, that kind of thing. So physical, we got filtration, separation of physical solids in the waste stream, many different technologies that can do that, ranging from basket strainers to get the big chunks out of a stream, like actual particles that you can see, feel, and touch, all the way to nanofiltration, reverse osmosis, getting really dissolved constituents, salt, sugar, that kind of a thing out of this waste stream directly, and everything in between. Float versus settle, okay? Tanks, gravity clarifiers, plate plaque clarifiers, dissolved air flotation. These are removing particulate material, or you make particulate material out of the waste stream and either float it or sink it, or do a little bit of both, and try and get it out that way using gravity, one way or the other. These are very effective in many food and beverage applications. The smaller facilities, you'll often see just a tank. They'll let it settle for a little bit, manually decant, but in larger facilities, you'll often see things like a DAF, and they're very effective, especially for fats, oils, and grease and other floatables. In wastewater treatment, the biochemical transformations happen using biology, and they can be split up into two categories: aerobic, where we're basically taking facultative and strict aerobes, converting carbon compounds into microbes using oxygen. The byproducts end up being carbon dioxide, water, and more microbes. It's a rapid process. It's what's happening at everybody's treatment plant, secondary treatment plant in some form or fashion, and is very effective for getting BOD out of a waste stream. Anaerobic, without available oxygen, it's a little slower and less complete. Especially at room temperature, it's generally a warmer temperature process. With greater odor control or odor issues possible. However, you can generate methane, biogas, and renewable energy. Okay, so for certain higher strength waste streams that generate enough mass, this is when you see folks going towards anaerobic treatment, and there's some other benefits there as well in terms of sustainability and being able to generate energy. So that's super cool. In terms of aerobic treatment, you basically balance air, time, food, and in those things, and you get spontaneous bacterial colonies that adapt to that waste stream. One thing about it, like we've talked about several times today already, the more consistent the environment you can provide, the better off you're going to be for biological treatment. And so you're really nurturing BOD removal, soluble BOD removal. You're nurturing an environment. You're creating an environment for living organism communities to do the work for you. Okay. The critical design process constituents, you're looking at flow and food. Okay, those things that we've already talked about, air and time. How much property do you have? And this is where you're starting to see some restrictions on some facilities. Is aerated lagoons, really nice, easy, simple technology, take up a lot of space. So there are some new modern constraints being placed on industry in terms of how much land area they have, encroachment from subdivision development, you know, the occasional odor issue in a lagoon once upon a time maybe didn't make much difference, now it does. All of that, and odor control itself, indirectly related to BOD. High BOD wastewaters have a greater opportunity for odor issues than low BOD wastewaters, for instance. Wastewater treatment chemical pH control, that's the one that's the most common, very beginning of a wastewater treatment train. Food and beverages in the US tend to be low pH, slightly acid, but caustic is often used in the cleaning processes. If you have a large volume to do that pH adjustment in, EQ tank, as Dan mentioned earlier, great way to do self-buffering. If you're doing it inline, smaller tank, lower capital cost, but you're having to buffer out all of the fluctuations in flow and load specifically, more difficult. And then chemical treatment further, it helps with filtration, coagulation, flocculation, often employed to assist dewatering of solids, and then float and settle, whether you're looking at creating a flux so that you can use a DAF or settling, increase settling efficiency in a gravity clarifier. Okay. And then overall, I'd like to end the treatment part of it by just saying, hey, the unit processes, just like this municipal plant, they're all the same. They're just going to be employed either maybe with a little more technology like a DAF for solid separation. But if you're looking at primary settling basins and grit removal and very analogous process-wise to a full treatment plant, but recognizing that in a lot of times we're looking at putting several of these treatment processes in a train on an individual property being managed by folks that make, French fries, as opposed to having a whole staff of professionals that are managing and have their whole goal be producing good, clean water. That's the challenge we're imposing on some of these industries. And making that as easy as possible is something that is big on my radar screen. And we can't ignore the fact that the stuff that they do inside the facility is huge for the efficacy of the downstream treatment. So they have a lot of control over what they do, right? If we put together a structure where they're incentivized to discharge all their stuff down because they've reached the highest level on their wastewater surcharges already, then you're going to have to deal with it downstream. But if in another situation, if they're incentivized to help source separation, good habits, not dumping the hose on the floor when they're done using it, all those types of things can really help as well. Doing water audits to figure out where your water is going. These things are available out there through different sources in the industry and can really help a facility lower the flows and the amount of water that they use, along with lower the BODs that are getting into that water to begin with. So in a larger picture side, you have primary treatment where you've got pH removal, or pH adjustment, and solids removal, biological, either anaerobic or aerobic, and then advanced technologies for generating reuse water. You can break it up into blocks. Most often you're going to see things on the left, in some facilities the middle, and we're seeing more and more and more interest in the industry in getting all the way to things like full reuse water. And
great, thank you, Bob. We have the first quick poll up. The first poll question before I get to, I think we only have one more question left on the online there, but the first poll question is, there are several opposites that come up commonly in food and beverage wastewater treatment processes. What are some of those? And you can select either high temperature or low temperature. And while you guys are answering that, there is one that came up about a brewery, Bob, for you, Bob, specifically.
Yep. Big topic.
Yes, when a brewery starts up, do they consider wastewater loads to the municipality, or is the responsibility of the municipality to educate and regulate?
That's an interesting question. When a brewery starts up, many times, at least what I've seen, they start out very, very, very small. These are, and I've got friends that have started up what are becoming very successful breweries in my neck of the woods. They literally started with a couple of kegs in a really an exaggerated home brew setup. And so the evolution is interesting because it starts out at a point where basically nobody notices, and it finally gets to a point where everybody notices. And it can feel very, very sudden for someone building a business. Hey, I've been doing this for 3 or 4 years. I finally get to the point where I feel like I'm making it, and now this. That's kind of the progression. I would say that outreach, communication, even at the earliest stages with any wastewater discharger is helpful. Even if the conversation is, hey, we're not going to worry about this until you get to such and such flow or such and such load, depending on how your program is set up. But want you to know that breweries do this. If you want some more information, we have some resources or whatever you have, best management practices published, that sort of a thing. I think communication earlier and more detailed is better than waiting, by far.
Excellent. Well, thank you again for your time today, Bob. This was a really great presentation. We have several folks chiming in that they really enjoyed the information that you shared today. We have the second poll up.
And I apologize. Yeah, I guess I didn't understand so the questions I put together, they didn't really match up with your polling structure. I apologize.
Hey, no worries. No, it's giving everyone an opportunity to confirm that they were here listening to your presentation. So
Sure.
we're all good on that. The second question was, do you have a formal pretreatment program? And 94% of the folks that answered the poll said that yes, they do have a program.
That's fantastic.
Yeah. All right. Well, we are going to thank you again for sharing with us today and take a 5-minute break in between the next presentation, in between this and the next presentation. So folks, we will, let's see. So at 10:10, we'll come back and start the next, we'll welcome Joshua Ballantine for his presentation.
Fantastic. Thank you.
Thank you. Okay, everyone. It is 10:10, so we will go ahead and get the workshop going again. I hope you had a chance to take a break, stand up and stretch maybe if you needed it, refill your coffee. Today, the next presentation is going to be by Joshua Ballantyne. Welcome, Joshua.
Thanks. I'm trying to figure out how to share my screen. Give me just 1 second.
Yeah, we'll go ahead. I'm going to shoot you a message here, and it should ask you to allow your screen to be shared. While you're working through that, Joshua's joining us from Memphis, Tennessee. He's a senior associate and project manager for Brown and Caldwell. Was really looking forward to hearing your presentation today. Thanks again for joining us, Joshua. I see your screen up, so screen sharing worked well. With that, I will go ahead and pass it over to you for your presentation, Josh.
Thanks. I appreciate it. And thanks everyone for participating today in the Pacific Northwest Pretreatment Workshop and listening to all the presentations. I appreciate you taking the time out of your day, especially to listen to a guy that's not necessarily from your part of the country. But I think what we have to talk about today is important to discuss and can be applied to pretreatment programs across the country. So just quick, I just want to talk, kind of give an overview of what all we will discuss today. And the topic specifically addresses enhancing source control programs. And so we'll kind of use that to segue into a case study kind of highlighting the city of Memphis and their pretreatment program and why they turn to digital solutions to help supplement their program. And then we'll kind of go into the specific case study about the project. So traditionally, pretreatment programs receive or conduct sampling at industrial facilities a minimum of 2 or 3 times per year. These sampling events typically include composite and grab sampling techniques, where a 24-hour composite sampler is set up to collect a series of samples and composite it into one large container to represent the discharge of that facility for that period of time. And then occasionally, we as pretreatment program staff, we may use discrete sampling techniques where we may have multiple bottles in the composite sampler, where each bottle may represent a 1-hour duration or a 4-hour period of time instead of an entire 24-hour span, to help us get a better understanding of cyclically throughout the day that diurnal pattern of not only flow but also pollutant concentration. And these sampling techniques have served the environmental regulatory community pretty well for the last several decades. However, there are disadvantages to this sampling technique, and that it truly does not, especially for the 24-hour composite sampler, sampling technique does not have any context to whether the discharge is stable or trending up or down. It also provides no context as to what the instantaneous maximums or minimum concentrations were during that sampling period. So now we look at enhancements that we can make to our source control programs that can help reduce the pollutant concentration at the wastewater treatment facilities or water reclamation facilities, to also provide opportunities for optimization of our treatment system, and then just the beneficial reuse opportunities of those valuable products that we generate. Today's technologies with smart sensors, Internet of Things or IoT, and advanced analytics, we can now capture and analyze this real-time data continuously. When we talk about enhancements that can supplement a pretreatment program or a source control program, a lot of times we focus just simply on water reuse programs, as a lot of times this is a requirement of their permit. But these enhancements are beneficial to any and all source control programs at any municipality or utility across the country. For example, we may develop or increase our public outreach programs, We may monitor industries more frequently or for more parameters, and maybe this includes these constituents of emerging concern, such as PFAS or PFOA compounds, which are so prevalent in our discussions across the country today. We then take all of this enhanced monitoring data one step further, and now we assess the fate of these pollutants in the treatment system, and we start a pollutant inventory tracking program. And then just taking that kind of to that next step, we may install a smart sensor network that measures various water quality parameters in near real time, which can be deployed directly at the industrial user's permitted monitoring point. We can couple this with additional sensors in the collection system and at the treatment facility or the reclamation plant. I'd like to introduce you to a concept of installing these sensors at industrial users, at the industrial users permitted points. There are numerous benefits to this. We first start with just identifying the parameters of concern that people would like to measure. We then identify specific sensors and install these sensors at the industrial user's discharge monitoring point. We may also install the same sensors, as I mentioned just on the previous slide, at the influent or the effluent of the water reclamation facility, the wastewater treatment plant, for impact analysis. We may then, we will then develop and deploy dashboards with advanced analytics, with the various thresholds and alarms or notifications, so that when we hit those thresholds, we then notify the pertinent people within the organization, or maybe even more specifically, we automate the notification to the industrial user that their industrial discharge is approaching or even out of compliance. And so, just a note, to date, we have not had any issues with pushback from these industries. In fact, it's been quite the opposite, and we'll talk more about this later. But it's actually been pretty eye-opening, the responses and just collaboration that we've gotten from the industrial users to date. So the benefits of smart sensor application vary depending on the location of where they're installed, but we'll just kind of go over several different scenarios. So they can serve as an early warning system for the treatment facility, providing that early warning of abnormal loadings that are headed to the plant. These sensors can also be coupled with composite samplers and trigger an actual sampling event when some threshold gets exceeded. So for example, maybe the sensor can't track some specific parameter, but all of a sudden the total organic carbon, or the COD, increases above a threshold that we can then trigger a composite sampler to start collecting samples at that point. And then we can take that sample and send it off for analysis to figure out what it is that's in the wastewater causing these abnormal loadings. They can be used for compliance and surcharge verification, similar to the annual sampling required by the federal pretreatment program, federal pretreatment regulations. We can use these to help minimize industrial user non-compliance. And then there's also a huge cost savings opportunity by using the real-time data to optimize the treatment system, or to better understand the loadings in comparison to dynamic treatment and operational changes needed in order to treat the wastewaters that are coming in. We can obviously increase MPDS permit compliance at the wastewater treatment facility simply by just using this data beneficially to make operational changes, or to know when abnormal loadings are headed your way to the treatment plant. We can make those operational changes that we need in order to protect the plant and in order to help protect the facility's permit compliance. And then finally, it can provide asset protection within the collection system by sensing corrosive conditions discharged from these industrial users into the collection system. So what do we mean by smart sensors? It's really just the concept that the data is collected, the data collection and the physical process drastically decreases human involvement just a large array of various water quality parameters. The data is collected and transmitted wirelessly and then can be analyzed in near real time. So now let's talk real world. Let's talk about the city of Memphis and their pretreatment program and how they have supplemented their source control program with these digital solutions. Memphis is considered a large pretreatment program with over 100 permitted significant industrial users. These users discharge on average approximately 30 to 50 million gallons every day to the city's 2 wastewater treatment plants. But what truly makes Memphis one of the most unique programs of the country is that the top 15 significant industrial users discharge 500,000 to 14 million gallons every single day of the year. And the organic BOD TSS loading from these users on average is 50% of the total loading to the plant and can be as high as 90% of the loading. So I just want to walk you through some images from Memphis's collection system to show you why Memphis chose digital solutions. So here we have an upstream CCTV footage where we just took a still shot upstream of an industrial user. This is the immediate downstream sewer of that same segment, just as after the industrial user ties in. You can see the tremendous amount of corrosion present with the aggregate showing just, from top to bottom. These two images are of the exact same location, about 1 year apart. And you can see, in this image, we obviously have a gaping hole in the junction box structure where several gravity sewer lines come together. But here, that same hole is drastically increased in size just over the course of a year. And this is a junction box where one major significant industrial user ties in. And then here, another image of a junction box where a couple gravity sewers and a force main tie in to the gravity sewer. And here it's just a tremendous amount of corrosion. That used to be a weir wall straight across, and now it looks more like a V-notch weir with exposed rebar and aggregate. It's just a tremendous amount of corrosion. And just to be completely honest, Memphis industrial users have struggled with compliance with pH, and so Memphis took it upon themselves to help figure out a solution to help get industries into compliance and to be able to track this in real time. So I'm just showing you the issues in the collection system. We haven't even talked about issues at the wastewater treatment plant. And so I think it's pretty obvious and apparent that the discharges from these industrial users truly can have an impact, not only on the collection system, but on the treatment facilities as well and how they operate. So Memphis decided to invest in a pilot study or a pilot project where 5 of these smart sensor water quality stations were installed at some select industrial users and at the influent of the wastewater treatment plant. These sensors continuously measured multiple parameters, but the primary parameters that Memphis was most interested in were BOD, TSS, COD, and pH. And obviously, the pH data, you can see from the previous images why we were so concerned with pH. The COD data was very useful because Memphis was in the process of implementing a new, or developing and then implementing a new COD surcharge on industrial users for high strength waste. And the data was used to quantify the amount of COD loading that was truly coming from each and every one of these facilities in real time. And then kind of ultimately this pilot project was a proof of concept. Memphis believed that this idea of smart sensors deployed throughout the collection system at select industrial users, and at the wastewater treatment plant. It had a lot of upside for them, and they wanted to verify that this worked and was a feasible solution for them to expand into. So just kind of as a high-level overview of the pilot project, it was approximately a 6-month-long project, and the sensors worked extremely well in the harsh conditions. They saw a lot of high temperature, with very wide swings in that temperature, very corrosive conditions. pHs were measured as low as 2 and actually greater than 12 in some scenarios. And then the other thing that was of concern potentially was just the very turbulent flows coming from these industrial users. And there was really no problems, no issues with that during the pilot project. Ultimately, the data appeared to be pretty accurate and very useful for Memphis. It showed a lot of industrial users that were really underreporting data with respect to BOD, TSS, COD, and of more interest was the pH data, which very rarely aligned very well with the data that the industrial users were providing back to the city on a monthly basis in comparison to the city's installed sensors. The maintenance schedules varied. The pH sensor, depending on where it was installed, and we'll talk a little bit more about this here in a minute, depending on where it was installed, required weekly to about every 3 weeks of cleaning and then calibration. And the multi-parameter sensors that we were using for BOD, COD, TSS, they required kind of hands-on cleaning approximately twice per week to about every 2 weeks. Once again, just kind of depending on the particular installation. So just to be fully transparent, this project did not come without some of its own unique challenges. However, for the most part, all of these were overcome by fairly simple solutions. The initial pilot, as I mentioned, it included 5 of these smart sensor stations. In order to see the data, you had to log in to each station individually. This was problematic in just trying to determine if an industrial user and their discharge was causing any impacts at the wastewater treatment facility. And so this was ultimately overcome in the next phase of the project, but I'll go ahead and mention it here with an integrated data platform, and we'll see some screenshots of that a little bit later, where all of the data sources were combined into one dashboard panel for viewing, easy viewing purposes. The sensors, they do require to be continually submerged to prevent fouling and just inaccuracies in the data. And so at all of the installations, for the most part, it was a continuous flow, 24/7. And so the sensors were continuously submerged for that. And in scenarios where they couldn't be fully submerged in the stream of flow because of, let's say, maybe an intermittent discharge, in those scenarios, we're able to overcome that with a flow cell, where essentially we just pump water up out of the flume or out of a pit or even a manhole, and then push that across the sensors essentially, and then discharge it back into that flume or into that manhole. And ultimately that kind of helps us to overcome that issue of it continually needing to be submerged. The other thing that's a little bit unique to this particular application or this particular sensor is that it does require on-site power. And so that was a little bit of a concern initially. However, working with the industries, it was truly tremendous. Memphis had a really good relationship with most of these industrial users, and ultimately the industries were great to work with. They provided power. In some instances, they even made some plumbing modifications so we could install the flow cells. And just overall, it was accepted very well from the industrial users. So now we're just going to look at some of the early dashboard panels that were put together for this project. And this one in particular was just looking at COD discharge from each facility in comparison to the wastewater treatment facility. And we do a little bit of data analysis on this, where we're totalizing the total pounds of COD coming into the plant. We also can average the COD concentrations. Excess COD for Memphis means the amount of COD that's discharged from industrial users that exceeds the threshold for surcharge. So they're receiving approximately 18 million pounds of COD for the month of May in 2018. However, of that 18 million, only 16.44 million pounds is surcharged. And so that was the purpose of this dashboard, was to truly kind of be able to drill down and see, total COD discharge, average concentrations, and then of all of that, how much of this COD is what we called excess COD that's surchargeable. So then now we move on to the next phase, which we call phase 1, and it included Memphis actually purchasing sensors. The previous pilot project was a rental project. Memphis did not outright purchase the equipment, but simply just rented it due to the fact that it was really more of a proof of concept. Ultimately, the proof of concept proved to be very valuable, and Memphis then moved forward with phase 1, where we purchased 10 sensors. We installed these at the permitted industrial monitoring points, and it was important for Memphis that the sensors were installed at the permitted monitoring point, not out in the collection system somewhere downstream of the industries. And this was just simply because Memphis didn't want industries to be able to state that, how can we 100% attribute data out in the collection system to their specific industrial discharge. And so we just wanted to eliminate that right off the bat. And so we dropped these sensors right down into the same location where Memphis would install, their 24-hour composite samplers. In some instances, we're literally hanging sensors into the stream of flow right beside the industrial user's pH sensor. The data is recorded by the sensor and the controller, and then we send it to a secure cloud-hosted server where we capture this data and ingest the raw data into a big data platform. And in Memphis's case, BC, Brown and Caldwell, we performed the installation and maintenance of the sensors for the first 6 months, and then developed a maintenance schedule strategy based on the performance of those sensors over the previous 6 months. So in essence, we essentially hand over all of this to the city to then implement with a maintenance strategy that shows them, based on the last 6 months, industry XYZ sensor requires cleaning and maintenance every 3 weeks. Industry ABC requires cleaning and maintenance, once every 2 weeks, so on and so forth, to just help Memphis understand how to maintain the sensors more effectively, more efficiently. This smart sensor network was also designed to be expandable and to capture other water quality parameters. So Memphis approached this kind of as a phased-in approach, where they wanted to start with just pH, just strictly because of the corrosive conditions in the collection system and some upset events that they had at the treatment facility. But they knew that they also wanted to capture flow, BOD, COD, TSS at a future time. And so the sensor stations are essentially expandable to where we can plug and play with additional sensors at a minimal capital cost to the city. So then here's just a couple, I think we have 3 or 4 different screenshots of the live dashboard that Memphis is using now. And this just shows all of the sensors and all of the data for a few days. And you can see we have them grayed out just so you can't see the industrial users' names. We don't want to really highlight some of the industrial facilities and the non-compliance events, but we want to be able to show you what the dashboard looks like. So we grade those out. You can click on their names up at the top to drill down into their specific data, or you can click on the circles over on the left hand side, which just kind of geographically represents their location within the city, to drill down further. You see at the bottom there, we have a slider bar function where we can easily filter for various date ranges or just one individual day if that's what you're looking for. So here's a drilled down screenshot from the previous dashboard where we just want to showcase what it looks like with just one industrial user. And this is a pretty interesting story, and it's the reason I specifically chose this industrial user to discuss. We installed this sensor, and within 30 minutes, this particular industrial user was already in non-compliance, below their permit limit of 5.5. They bounced up and down, in and out of compliance for the rest of that day, and then dropped down, in the 4s, even below 4, and for really and truly the next 3 days. And this was one of the most eye-opening experiences, not only for me, because I had no idea the severity of pH non-compliance, but for the city. And Memphis was already in the process of working out an enforcement strategy with this particular industrial user. And seeing this real-time data truly changed the way Memphis took enforcement action with respect to this particular industrial user, because their pH it's just so corrosive and so out of compliance that the severity was just really drastic and very eye-opening. And I will say this: some of the images that I showed earlier in the presentation, where I showed the upstream and downstream side of this collection system, this is at this particular industrial user's discharge point. So I think, just looking at the data, seeing where we were, hovering around, between 3 and 4 for a couple of days straight, it's obvious why the collection system looks the way it does. Memphis utilizes the Linko CTS database to help assist them in compliance tracking, and so on and so forth. Some of you may be familiar with that software. It's essentially what it winds up happening is all the data comes in at the end of the month or for the previous month and gets put into the Linko database, and then they can run compliance on that data, take enforcement action, so on and so forth. One thing we've been able to do that's been really cool for Memphis is that through APIs, we can actually pull data out of Linko and push it to our dashboard. And what we wanted to accomplish here is we wanted to confirm and verify the data that industries are reporting in comparison to the data that we're capturing at those industrial users. And you remember I told you earlier in the presentation that during the pilot project, this data did not line up very well. And that's still proving to be the case even now in some instances, where what we're doing is pulling out the industry's daily minimum and maximum reported pH and comparing that to the smart sensor daily maximum and minimum pH. And I just pulled a random day. This just so happened to be back in March. But what I did was just showcased here on March 20th, this particular industrial users, their reported maximum pH was 6.93, yet our sensor, just off of a fresh calibration the day before, measured a 9.92. And then you can see the minimum pH showing 6.04 and our pH minimum showing 3.75. And so this was a real important part to Memphis with this digital solution. They wanted to truly not only be able to see in real time the data that's coming in, but they wanted to have an easy way to compare it to the data that they get routinely from the industrial users. And then I think this may be the last slide on the dashboards. This really kind of helps break down the what we'll call permit violations or pH exceedances. And so we do this in a couple of ways. We do it kind of as a whole. So all 10 industrial facilities, we totalize the number of minutes that they exceed their pH limits per day, and we're showcasing that in these bar charts here. So you can see, you know, on March 12th, we had 2,100 minutes of total non-compliance from those 10 industrial users. Fast forward just a few days, we had approximately 4,000 minutes of non-compliance amongst those 10 industrial users. We then break that down a little further and look at who's actually causing those violations for this specific date range. So once again, we have the slider bar function where you could look at it on a month-to-month basis, you can look at it on an individual daily basis, and you can look at it on long-term, like 6-month, 12-month time frame. And then we break it down just a little further of all the pH violations. Memphis wanted to see kind of how it broke down with respect to specific pH ranges. So we just want to know how much of it was below 5.5 or above 10, which is their permit limits. And then let's take that one step further. How much of it's above 11.5 or 12.5, and then below 2. Those were the ranges that Memphis was primarily interested in seeing. So what's truly amazing about this project is that it not only just the fact that Memphis now has access to real-time data, but the fact that it has drastically reduced non-compliance from these industrial facilities. So we just captured the first 2 weeks these sensors were installed at the 10 industrial users compared to just a random 2 weeks that we selected back in July. And we saw the total minutes of pH non-compliance decrease from over 40,000 minutes to just over 8,500 minutes. So on average, they were violating 3,100 minutes per day back in March. Then to them, fast forward that to July and only be violating approximately 658 minutes. And that's a 79% reduction in pH non-compliance, and that's truly what Memphis was seeking to achieve. So phase 1 is still ongoing, but has been very successful up to this point, as the previous slide mentioned. Once again, the sensors are working pretty well in very harsh conditions and providing reliable data that can then be used for data-driven decision making. The dashboard panels have been a great addition to the digital solution and has been very well received. It's easy to access, and anyone can access it from anywhere. That's the benefit of it. It can be used from your workstation, to your tablet, to your cellular device. Anywhere you have access to this particular dashboard, we're utilizing Power BI. So anywhere you have access to internet or cellular service, you can hop on the dashboard and take a look and see what's going on. The maintenance, as I mentioned earlier, it definitely varies from station to station. And I'm just going to be I know this is a very non-technical terminology that I'm fixing to use, but it honestly depends on how dirty the wastewater truly is. And I'll explain that a little bit. What we've seen is that industrial dischargers, the wastewater that they discharge, requires less cleaning and calibration maintenance than the sensors that we're installing in collection systems and at the influent of the wastewater treatment plant. And I say that to say that, once again, the word dirty is not very technical, but what we are seeing at these industrial users is that the temperature is relatively high in a lot of their discharges, and so that helps fats, oils, and greases from solidifying, kind of caking up the sensors. The flows are usually relatively turbulent, so that kind of helps slough off some of the solids that would accumulate on the sensors. And so whereas in the raw wastewater of the collection system or in the headworks of the wastewater treatment plants or reclamation facilities, we have a lot more grit and grime. We have a lot more floatables. We have a lot more ragging and issues with that. And so I say all that to say it's totally dependent. I know that'll be a question later. How often do you have to clean and calibrate? It's totally dependent on where they're located, and it's really site specific. The way we approach it is we try to make an assumption of kind of what the minimum frequency is going to be, and then we adjust that as needed throughout the life of the project. And then we hone in on that towards the last part of it. And then once we hand this project over to the city, they then know what those operation and maintenance, cleaning calibration frequencies are. I will say to date, since February when we installed these 10 sensors, we've had to replace 5 of the 10 pH electrodes. So, that's pretty standard and typical with industrial pH monitoring. I actually thought we would have had to have replaced more electrodes. So we're really doing pretty well from that perspective. And then ultimately, the high level goal that we were trying to achieve is to help Memphis's pretreatment program become more effective and more efficient in implementing their program. And this has been achieved through this project. As you see, we've helped them reduce pH non-compliance by 79%. Imagine, you as pretreatment managers, pretreatment coordinators, pretreatment staff, if you could pick, a parameter that you have the worst compliance record with your industrial users, and then reduce that by 79%. Imagine how much more time that frees up for you in doing other things than focusing on non-compliance. And that's definitely been the case for Memphis. One thing I want to touch on real quick in our last few minutes is that kind of secondarily to the dashboard and real-time pH monitoring sensors that we're installing for Memphis, we're also helping them integrate multiple data sources into one integrated data platform. So just kind of real quick, we'll run down a few of these. We're going to pull in all of their Linko industrial discharge data. We're going to pull in data from the laboratory that they have. They also have a separate what they call wastewater information management system, or WIMS, which includes a lot of process data that doesn't come out of the lab, but is actually conducted by operations staff, as well as some lab data. And then also pull in some meteorological, hydrologic data from USGS and the Army Corps of Engineers. But more importantly, we're going to pull in this real-time industrial discharge data as well as SCADA data from the treatment plants to then truly be able to start trending and tracking potential issues within the plant or potential issues out in the collection system or at industrial users. So let's take, for example, we see an increase in the influent and effluent TSS. We can then pull up, SCADA data to check operational parameters. We can pull up the real-time sensors to see which industrial users in the last 24 hours have discharged higher than normal suspended solids loadings, so on and so forth. So it's really going to be very useful and provide a lot of opportunity for optimization, and cost savings from energy perspective, as well as maybe even chemical perspectives. So just to kind of wrap things up, Memphis's Public Works Director, Director Robert Connect, has a vision of being a leader in how a public utility can become a smart utility in leveraging digital solutions. Some of those solutions that Memphis is looking to move forward with are expanding the smart sensors at the industrial users. And so I've already talked about how we've piloted this. We're in phase 1 right now with just capturing real-time pH. We're already working on towards phase 2 now and scoping out that project. And it's going to include BOD, COD, TSS sensors, as well as the potentially UV spectral fingerprinting at the influent of the wastewater treatment plants as well. We're also looking to help kind of supplement the Linko CTS database with workflow dashboards. So we'll pull data out of Linko and then provide a display of various workflow related things, such as, you know, permits to be issued within the next 6 months. We can drill down and see which inspectors are required or are over this particular industrial user or this particular permit that's coming up within the next 2 or 3 months. We can trend non-compliance data. So for example, we can have a running list of the top 10 most non-compliant industrial users. That way, management can look at this and use this to help them make decisions on, you know, where they need to utilize their resources. We're also looking at automating real-time data ingestion back into their Linko CTS database. So we're capturing all this pH data right now. Memphis wants to use that for compliance purposes, but needs it in Linko so they're not manually having to take enforcement action. And it's all trending and calculated in the database once they start doing their annual report at the end of the year. And then just kind of briefly, we'll talk about the wastewater treatment plant. We're expanding the integrated dashboard. We're going to include some analytics. So we're going to look at disinfection in comparison to COD loading and color coming into the head of the treatment plant. We're going to look at energy usage in comparison to real-time BOD, COD, TSS data to see where we can optimize our energy usage, specifically with the aeration and blowers. How can we decrease that based on a dynamic approach? We're going to look at predictive and prescriptive analytics, where essentially the database or the dashboard becomes smart over time. And when we see a certain potential, you know, a certain discharge from an industrial user, we can then correlate that to a potential influent loading that's headed to the wastewater treatment plant. And then in the collection system, Memphis already has a lot of they have a lot of pump station sensors, but it's all on various dashboards, telemetry devices. They also have a lot of level sensors throughout the collection system to help track sewer overflows. And so we want to just integrate that all into one dashboard to make it easier to use, and then to help them actually start predicting and preventing sewer overflows. So that's all that I have today. I appreciate everyone participating, and you know, I hope that you were able to get something out of this. I just wanted to showcase some of the cool things that other utilities are doing throughout the country, and I truly do believe that smart sensors is going to be the future of pretreatment, and it may take a little while for it to catch on, but it's truly tremendous in its capabilities to help pretreatment programs become more effective and efficient at implementing their pretreatment program.
Excellent. Thank you so much, Josh. It was really neat to see how you guys are leveraging technology to help us, you know, in our pretreatment programs to help us do our job. So it's really fascinating case studies. A fascinating case study. We do have a few questions here for you. We are running out of time, but I think we've got time for quite a few. We're going to get some questions going, and then we will pull up the polls. Oh, yep,
no, I already put the poll up in because of time.
That's okay.
Sorry.
Yeah, no worries, no worries. Like I said, thanks for your patience, guys. We're still dialing in this question and answer with our polling process. So we had two questions about the UV spectral fingerprint monitoring parameter. Can you provide an overview and how is it usable?
Yeah, so the UV spectral fingerprint essentially uses UV light and absorbance to develop a curve across varying UV wavelengths. And then that curve essentially develops what they call a fingerprint. And that fingerprint can be compared to textbook data to help determine what the potential pollutant can be. And so a lot of the sensor vendors that we use talk a lot about how, maybe their sensor just specifically doesn't measure zinc. However, the UV spectral fingerprint and zinc has a specific UV spectral fingerprint, and so that data can then be correlated to, a particular parameter to help them narrow down maybe the project that they specifically always refer to is the influent of the wastewater treatment plant is getting a slug discharge. The UV spectral, and they don't know what it is. The UV spectral fingerprint can help aid in determining you may not actually capture actual concentrations, but could help you narrow down the particular parameter that is being discharged at high concentrations.
Okay, great. Thanks for going into a bit more detail on that. Did the city have to alter their sewer use ordinance for the use of the sensors?
Memphis did not. Memphis's ordinance was written generically enough to give them the authority to conduct monitoring. It didn't go into a lot of detail about what monitoring specifically is. And so for Memphis's case, this was really no different than going and installing a 24-hour composite sampler at the monitoring point. It's the same. It's essentially the exact same thing. And so to answer the question, no, there was no modification to their sewer use ordinance that was required.
Okay. Would you be able to give a general cost per installation?
So I know that's an important question to a lot of the viewers. It's totally dependent on what water quality parameters you're trying to capture. So it's really not that cut and dry. I can tell you that just purchasing, in Memphis's case, the pH sensors that they are currently using, that total station is somewhere, just the sensors alone and the telemetry device, that station's somewhere in the maybe about the $3,000 to $4,000 range. As you start adding additional water quality parameters such as the UV spectral fingerprint, BOD, COD, TSS, those sensors are a little more expensive, but plug and play directly into some of the existing infrastructure that Memphis already has. So they're not having to buy a total station. They're just having to simply add an additional sensor to a station that's already there and working.
Okay. We have a question about the data being shared with the industrial user. Were the industrial users with monitoring stations given access to the data generated? Did they improve their own compliance, or was it because the pretreatment program showed them the data and required compliance?
So to date, Memphis has not given access to the database or the dashboard to the industrial users. We have on occasions provided data sets electronically to the industrial facilities, but it's still as I mentioned earlier, phase one's still ongoing, and this thing's like 98% complete. But we're still not 100% to where we've turned it over to Memphis. I'm not sure if their plans are to turn this to provide access to the industrial users consistently, or just have the industries request the data. But up to this point, the industries are not able to just log in and access the dashboards. Memphis, we really believe that the tremendous decrease in non-compliance is just it's multiple things. It's the fact that Big Brother's watching continuously, right? So Memphis has sensors installed at 10 of the largest, but also 10 of the most non-compliant industrial users. Now Memphis can see what they're discharging on a real-time basis, anytime, anywhere. And so what we've seen from being in the field, maintaining, calibrating these stations, is that industries are maintaining their own monitoring equipment at a much higher frequency, and then therefore we think it is transposing into an increase in compliance.
Okay, great. I think we have time for one more question. We've had several and a lot of comments, Josh, just saying how tremendously useful this presentation was. So thanks again for your time. There are quite a few folks from out there on the East Coast attending today. We've got about 250 attendees and a wide range of locations that they're tuning in from. Let's see, so our final question here that I think we can get to today is how comparable are online BOD sensors with the standard laboratory method?
Yeah, so the sensors that we're currently using, they have a pretty high accuracy. And so just to be fully transparent, the BOD, the TSS, the COD, it's not an approved DP method. It still requires wet chemistry in a laboratory setting. But these are extremely comparable to that. They are essentially 98% within 98% accuracy of the the approved BOD, COD, TSS method. And so we're actually doing some work with Memphis on that very topic, where not only do we want to install the sensors, capture the real-time data, but we're going to take about a 3-month period and track this data in comparison to actual composite and grab samples to verify its true accuracy at each installation site. So, but I can tell you from experience that they are extremely accurate. However, I will say that one thing that you have to do is maintain them. They do have to be cleaned relatively routinely, and without cleaning those sensors, the data starts to drift, and you can actually see it visually on a graph. So but yeah, the data is plus or minus 2% accurate in most cases.
Okay, thank you. Well, we did have quite a few more questions, so we've left Josh's contact information up on the screen for a little while longer. So if you do have some questions that we weren't able to touch on, feel free to get in touch with Josh or send me an email, and we will follow up with him. Again, Josh, thank you so much for joining us today, all the way from probably 2,500 miles from where we're usually located for this workshop. It was a really great presentation. So cheers, and I hope you have a great rest of your day.
Thank you. I appreciate the opportunity.
Thank you. All right, guys. Well, we are moving into our next presentation. Today we have Betsy Hansen with Swift Comply. Betsy, welcome, and thank you so much for taking the time to share with us today. Let's see, I may have Betsy on mute. She's joined us. Let's see.
Can you hear me now, Andrea?
I can hear you, Betsy. Hello there. Good to hear you.
You too. Thank you.
Yeah, well,
Let's
thanks
see.
again.
Is my screen showing for everyone right now?
Not quite yet.
Okay.
Let me see if we can. I think we've listed you. It should be showing your screen. Hey, Ari, can you see your screen? I don't see it yet, but perhaps mine.
I cannot. It just says waiting to view.
Did you click yes, share your screen, Betsy? You will have to click in the positive to allow us to see your screen.
Get a prompt, actually.
Okay.
Let's see here.
Let's go ahead and try that again. Let's see. I'm going to take it off.
There we go. Oh, you took it off.
That's
okay.
mine. Yep. And then here we go, Betsy. Let's try this again. Thanks, folks, for being patient.
Oh, here we go. There, we've got it. Let's see here.
All right, we got it. I can see your screen now.
Got it. Okay, sorry about that.
No worries. And we can see presenter view, so.
Great.
Looks
You
like
can see presenter view. Perfect.
Yes. Oh, no, it's not in presentation view. It's in, yep, there we go.
Awesome.
Okay. Well, again, welcome. And I'll pass it over to you then. Thanks, Betsy.
Great, thanks, Andrea. I appreciate it. Welcome to the last session of the day, I believe, and I think it's been a pretty technology-focused day. The technology that I'm going to focus on is more around, in general, the types of systems that folks are using to manage their pretreatment programs. So let's see if this advances. There we go. So just to give you a little background, I work with Swift Comply. We create cloud-based software solutions for program management, as we've talked about, both for in the water and wastewater worlds. Our solutions aim to tie together the different stakeholders of the programs using digital tools. And we also have a goal of allowing program staff to focus on outreach and compliance instead of paperwork. So that's kind of where our tools come in. My role as product owner means that I'm in charge of developing features that contribute to a great customer experience and great success for our programs. I've been working in software development for about 20 years, but I've actually only been with Swift Comply and in this industry a little less than a year. So I am new to the industry here, and I've been working in the FOG arena, and I'm now moving into building and rolling out our software for pretreatment programs as well. And in doing that, I was picking Andrea's brain here and there on different features and things that would be useful in the pretreatment arena. And she had mentioned this event, and we talked about ways that I could get involved, both to learn and to share some of our experience. And what we talked about was finding a way to help folks understand what types of systems are being used now, and what are the different characteristics of pretreatment programs that would affect what systems make sense to use. You know, to me, if I was running a program, I would want to know why and when should I consider using software for different elements of my program. So we talked about how we might be able to answer some of these questions. And one of the ways we talked about was putting together an anonymous survey of different programs to just get a sense of what's going on now and see if we could determine some factors that would help drive which way people are using different systems for different features. So we designed that survey, and I have big thanks to Andrea for helping me do that and helping get the survey out. Also, big thanks to Shane Sinclair, who worked closely with me to make sure that the survey questions made sense and to just give me a gut check on making sense. So I really appreciate you guys helping that. So what we're going to do is run through the actual survey and look at the responses we got and what they seem to say. So here's my disclaimer. I am not a statistician by any means. There's lots of things that can affect the validity of kind of observations that we take from survey data. We have a relatively small sample size. Some of the questions probably aren't as precise as they needed to be, which sometimes you don't know until you get the answers back. There's also, you know, it's easy to kind of see that pieces of data may be related. So the use of one system may be related to how many SIUs or CIUs you have in your program, but it may not be the cause. So it's also, you know, one of those things we need to keep in mind when looking at survey data. And lastly, this is version 1, and this is kind of our first take at collecting this information. I hope that you'll be willing to provide feedback both on the actual questions that we asked, but also the analysis going forward. And it's certainly something that I could have spent weeks and weeks digging into the data even more. There's a lot there. So I appreciate you listening through it and understanding that this is not our profession here. Okay, so for the actual agenda, we'll run through what we asked in the survey, the demographics of the responses, what that data seems to say, and then what you might be able to take away from that. And I don't know if Andrew mentioned it, feel free, if you're typing in questions, Andrew, feel free to interrupt me if there's anything that I can answer along the way.
Okay, we'll do that. Thank you, Betsy.
Thanks. Okay, so when we designed the survey, we wanted it to be anonymous so that people wouldn't feel like they were, telling a software company what software they're using, things like that. We wanted to collect different factors that might affect what systems folks use. So you'll see on here, there's 5 different program details. This presentation is going to focus really on the first 2 because that seems to be where we got the most information and kind of the most tie between the information. And then the 2 areas that we wanted to look at were what systems folks are currently using, and then what type of interest there is in digital solutions for different aspects of managing the programs. And I've highlighted the current system usage because that's pretty much where we're going to focus. I can run through quickly at the end where we landed with the interest in digital solutions, but there really wasn't as much kind of meat in that part of the survey. Okay, so I know that everyone's really tired of seeing maps of the US, but this is just a map to show you where we got responses from. So we had 48 total responses. And again, we cut this off a little bit early, like maybe even a week and a half, 2 weeks ago, to allow time for analyzing the data. But I'm really grateful that we got, I was aiming for 30 responses, so 48 was great. They came from 14 states in Canada, and I don't know how typical that is for this event of that kind of spread across the US, but I thought that was pretty interesting. Tabulated altogether, there were 1,048 SIUs or CIUs covered by these programs, 551 program years across there, and 1 Amazon gift card to help get people to participate, which we haven't announced yet. So it has nothing to do with participating in this presentation. So we will do that in the follow-up. Okay. So just to give you a sense of how it broke down, this was a little bit of a back and forth during the analysis to figure out what buckets to create for these characteristics. So number of SIUs and CIUs ended up breaking out into less than 10, 10 to 30, 30 to 60, and more than 60. And this just seemed to be where there were differences in the responses. You can see they're not like evenly distributed across the programs. There's a lot more data for the smaller side than there is for the larger side. That's how it broke down that element. And then the other element we broke it down, which is a little more distributed, was the number of FTEs in the program, less than 2, 2 to 5, and more than 5. So I'm going to jump right into the question we asked about what types of systems folks were currently using. And this is my rainbow systems spectrum. And these are the categories we used. We tried to keep this pretty general and not system specific. So going kind of from the more manual end of the spectrum with paper and Excel into a general database, which, is like Access or something like that, where, it's customizable in that you can define your tables and your data, but there aren't like a whole bunch of features that are customizable in there. And then as you move to the right, these are more defined software programs. And then within that, we break it down into the first, the green, the city management, those that are more generally used for multiple programs within a city. The second is an off-the-shelf, meaning there's a predefined way to use that program, but it is specific to pretreatment. And then the most custom is something that maybe an internal team, internal IT team built, or maybe a third-party developer built for your program. It's specific to pretreatment, and it's also customized to how your program works. So that's sort of what we're looking at in the spectrum of systems. And that's what we used to ask the questions here. And you can see this was kind of a tabulation of across, I think it was about 12 features. We asked for each of those features, which system do you currently use, or which type of system do you currently use for those features? You can see it's pretty well spread, but there's definitely two areas of focus. There's kind of the manual end with paper and Excel, and then there's the super custom end. So what we're going to do is try and break this down a little further, both by which features as well as the program characteristics. We talked about the number of SAs and CAs and the number of FTEs, and see if there's any correlation there between those program characteristics and what systems are used. So I'm starting out kind of all the way at the manual end, those that had the highest use of paper. In general, I mean, I think, you know, a lot of this is pretty straightforward, but just to kind of keep it in mind when you're thinking about the different features or aspects of your program that need to use the system, the pros of, you know, having a paper-based system obviously is a low initial cost. It's very customizable, and there isn't a tech requirement for either your staff or anyone else that is contributing information. So whether it's the industries, there's no tech requirement on anyone, right? But the downsides obviously are paper in itself. It takes a lot of time for staff and teams in general to collect and store and find that data once it's stored. And so that low initial cost can get balanced by a lot of manpower work. It's also hard to monitor for compliance. So there isn't any way to easily tabulate or see across history any of those places that you might be able to see issues arise or see compliance for that matter and know that everything's being done properly. It's also difficult to collaborate and share within your team in a paper environment. But let's go through and look at which features ended up with the highest use of paper. And I don't think they'll be terribly surprising in a lot of ways. Notifications and communications, some of these are required to be done via paper, so that makes sense. And they also depend on the industries or anyone else communicating to be willing to get these notifications and communications online. So that's certainly a barrier to getting away from paper. Similar enforcement kind of goes right in that same bucket. I think reports to EPA is probably a different reasoning for high use of paper. You know, we didn't do any analysis on those reasons. So these are kind of, you know, guesses as to why, but that I think is just a very complicated and specific application, and a lot of folks need to have the paper means to do that. And permits, I would guess, it sometimes is a separate department or system that is outside of the control of the program necessarily. So that could be why paper gets used in that one as well. Let's see. So breaking down those features, this is what the first one, notifications, looked like in terms of which system people are using. You can see it's pretty predominantly paper. And so what I tried to do for each of these features is look at the 2 program characteristics that we're focusing on to see if there were any trends. And I took the 2 or 3 most common system types for each. So in this case, the most common system types for notifications and communications were either paper or custom built. And so we looked here at what the breakdown was as you move from less than 10 SIA/COUs up through the greater than 60. You can see in general that the use of paper goes down and the use of custom built system goes up. So that kind of makes sense. The others were just lower frequency of that system, so we didn't really analyze those as much. So this is by SIUs, and it's pretty similar by FTEs. You'll see, and I'm going to go through and do this analysis for each feature, just because one of the things we're trying to do is see whether these characteristics are related to usage. So it looks like a lot of data and information on here, but I think it'll allow us to summarize it at the end. So continuing on the features that were paper focused, enforcement's broke down pretty similarly. So, you know, custom built and paper, but paper really dominates. Again, this is the breakdown by SIUs, and it's pretty similar. The breakdown by FTEs is a little bit harder on the paper side to really see, and that may be, you know, as we're talking about where we make these breaks, the less than 2, the 2 to 5, and the greater than 5, those may not be exact in terms of predicting behavior. So there's always that. The last, I think this is the last one that was very paper focused, reports to EPA, as we talked about. It's pretty similar. This one has a little more Excel in it also, and I'm guessing that's due to some of the analysis involved, the data analysis involved. But again, the breakdown is pretty similar. The trends are pretty similar for SIUs and for FTEs. This one is a little different than the rest that we see the Excel having a different trend than the paper. So again, I think that probably speaks to the data heavy portion of the reports to EPA. Oh, there was one more, sorry, permits also was paper. And this one, you'll see that custom built pretreatment specific system is also creeping up in this case. So it's still pretty paper focused, but there is that other element where the custom system does come into play. These are not too clear cut, that custom system one, the rest are by SIUs, but it's really clear cut by number of FTEs. And the breakpoints seem to be pretty consistent there. So there was another next category of features that all had their highest system type be Excel. And again, you know, we didn't do analysis of why for each, but here's some characteristics, some pros and cons of Excel that might lead folks to use it for different feature types. So similar to paper, there's, you know, a low initial cost and it's pretty customizable. There's a little more of a tech requirement than paper, but it's still pretty low. The great thing about Excel in this case is for applications that have a lot of data points, there's obviously much more analysis and reporting capabilities. And there is a little bit more of an ability to share snapshots and graphs and charts and ways to see what is happening and share that with your team. I think the downsides to Excel in this case would be that you're still not getting any analysis or compliance overview or information without someone manually going in and monitoring that information and doing the analysis. And typically one person owns Excel sheets in that way. So it's a little harder to work as a team in this type of environment. So let's go through the features that had high use of Excel. And not surprisingly, lists of SIUs, CIUs, and non-SIUs was probably makes the most sense. It's a great place to store lists and be able to manage that information. Similarly, the sampling result calculation is something that lends itself well to Excel, as we said, from the data and analysis standpoint. So you'll see when we start going through these three, there's a pretty marked difference that Excel really dominates these feature areas. And again, similar to the paper ones, it's the custom built does come up in a lot of these, and we'll get into that in a minute for the items where that's higher. So looking at the SIUs and CIUs, whether that's predicting the usage, it's pretty good for the list of SIUs. FTEs is probably a little better predictor. Sampling results, similarly, we see pretty much the same breakdown of the different types. And in this case, looking at SIUs isn't quite as good as looking at FTEs for predicting. Let's see, list of NSIUs. This one's a little different. This was a pretty spread out a little more, even though Excel was still in the lead. This one spread out a little more across all these different types of systems. Again, we broke it down by SIUs, and this one, I would say that one's not working at all. I think SIUs is probably a better predictor for this one. There were a couple where paper and Excel were pretty even as the leaders. Annual reports and surcharges, and again, these are probably the ones that are data heavy, and it's just interesting to see that the two were pretty equal, as you can see here, and they do follow relatively the same trend here, the paper and the Excel. And then you always see that custom one creeping up. In this case, they're a little different in the annual report, at least by FTEs. The Excel portion seems to increase with the number of FTEs while paper is going down. Surcharges, this one was a little more clear, pretty isolated to paper and Excel.
Hey, Betsy, we do have
Yeah.
a question
Sure.
related to, I think, 2 slides ago. Does custom built include Excel Visual Basic, or does it only include built from scratch systems?
I don't, it sort of depends on how people answered it. I would say the intention of the question is that the Excel would not include kind of customized programming on top of it. But I can't guarantee necessarily how people answered it. Does that make sense?
It does. Yes. Thank you so
Okay.
much.
But I think, getting at the Visual Basic and customization on top of Excel in terms of how we intended it would fit more in the custom solution. Going back to surcharges here, we were just looking at whether the SIUs are a good predictor or the FTEs, and obviously I think the SIUs are a better predictor. And then the third category of features was those that had the highest use of the custom built category. And some of the pros of custom built, as we were just talking about, would be that it's customized to how the program is run and the specific items that are needed for your ordinances or for your staff or for your policies, however that is required. There's more analysis and reporting capabilities typically. And this is kind of where the data can be extracted enough to really focus on compliance. The system can analyze data behind the scene and monitor for either issues or monitor for compliance that, you know, this industry does not need to be, you know, re-inspected or investigated at this time. These are all going well, and it can bubble up issues that may need to be addressed. And with any kind of custom built system, the cons are going to be initial cost and setup time, of course, but system overall compliance and overall efficiency may weigh those out in the end. So the areas that seem to have the highest use of custom built systems, inspection results, sample results, self-monitoring reports. These seem to be areas where there's both a lot of industry specificness to those elements and also a lot of customization across the program. So it makes sense. Most of these are not surprising, but you can see that the gray bars next to there, there's not a huge gap. There is custom built system being used across the board, but these are the three that really stood out for using this types of system. So sample results, you can see, like I was just saying, it's pretty spread out, but the custom built really does win out in this category. And we can look at SIUs are a pretty good indicator in here for what type of system gets used, and FTEs. For inspection results, I think this is pretty typical in that the balance is between the paper and the custom system. And these again are really good indicators, the SIUs and the FTEs. Both of them react the way that you would expect. Self-monitoring reports actually seems to be pretty spread out. And the indicators, they're still pretty strong in these as well, but not as strong as some of the others. And let's see, was that? Okay, so that we're kind of getting into the area where the last bucket of features is that there's no real clear winner on which type of system is used. And this one, to me, probably means that this is a feature that's hard to come by in most systems, that the system itself isn't able to deliver a compliance answer, that it still requires a human to go in and monitor and manage the data in those systems to come up with compliance answers. So you'll see it's pretty spread across there. And there's not really too great of indicators by the size of the program. So the things that we were hoping to get to in doing the survey are predicting usage. So finding those factors that will help a program understand, does it make sense that I'm using Excel at this point? When is a good time for me to consider going to a more digital tool or going to a more sophisticated program that can manage the data differently? And so in this case, I went through and just a little bit anecdotally looked at which was the better predictor of system usage, and those were the graphs that we stepped through earlier. And they're pretty equal. I think that the number of FTEs might have been a little bit of a better indicator, but they're both pretty good. So those are both tools that you should be able to use to look at your program and evaluate what type of systems might make sense. So within that breakdown, the other information that I think would be pretty helpful in coming out of this survey is what's the number of SIUs or CIUs where this transition in behavior seems to happen. So we saw that a lot of the time at the smaller end of the number of SIUs, paper and Excel were really leading the way. And where is it that the transition happens to custom built or even to off-the-shelf solutions, where those seem to make more sense? And so in the data that we collected and looking at how the lines behaved, it looked like the 30 SIU CIUs was sort of the tipping point for where the behavior changed, where the type of system changed. Similarly, when breaking down the program into number of FTEs, where's the transition where that behavior seemed to change? And in the data, it seemed to point to about 5 FTEs as where there's a real different usage of systems. And this could be around collaboration and sharing and how many people need visibility into the data and information. So overall, I think what we were trying to achieve was what can you take away, and how can this survey information maybe help you approach system use for your program. So it allows you to see what other folks are using, estimate those tipping points we talked about, and there's others. We tried to get at kind of ordinances, whether they're similar to kind of the EPA model or how different they are, how strict they might be, whether your pretreatment program is combined with your FOG program, whether you're doing surcharges. So there's definitely other factors that that we didn't go into as much analysis on, but there's certainly other tipping points probably within program size and complexity. And the other thing is to help you realize that different aspects of your program and different features can be using different systems, and that there may be certain areas that require a more sophisticated approach before others. And so this maybe will help you see how folks are doing that now. I welcome any feedback about and questions about the survey itself and about the analysis. There's a couple other areas that we did ask about that I can walk through that I think we suffered a little bit from this being our first time in question design, around figuring out the interest level in digital solutions for the different features. Let me just show you quickly. So we also asked 3 questions about each of the features. Were you interested in a digital solution? Were you interested in a digital solution only if it was Cromera compliant, or were you not interested at all? And we can, I can report on kind of what we saw, but what had ended up happening was it seemed like about a third of the programs answered interested in digital, about a third answered not interested, and a third answered interested if only if it's Cromera compliant. So we didn't end up getting a lot of granularity, and what we ended up, there's a couple that stuck out, but they weren't much higher than other areas. And so I think that we probably should have asked what are the top 2 or 3 features that you would invest in getting a digital solution. So generally, I mean, the interest is high, that 2/3, when a third answered no, the other 2/3 all answered yes, they're interested in digital, but I think the question needs to be redesigned to get a little more information. Let's see. So are there any questions about the survey itself?
I haven't had any additional questions yet, Betsy.
Okay. Okay. Great. Let's see, I'm trying to think if there's anything else to go over in there.
There's a lot of really good information and very interesting to see the survey results and analyses.
Yeah, I think it'd be interesting to see if it changes over time also. And as we, like I said, improving that, improving the question that's more around what people are looking for or interested in doing would kind of be the next level of information there.
Right. Yeah. I wonder if there would be an interest among the folks that are listening in now to either retake or have an opportunity to take this survey so we can perhaps share the info. If you are interested, go ahead and let us know in the QA box. And perhaps if there are any folks interested in maybe doing a second round of data collection now that we understand, just chime in and then we'll gauge it from there. That sound good, Betsy?
Yeah, we could do that. And like I said, I mean, I think we had kind of cut off the responses that we put into the analysis at 48, and there may be more that would give us a better sample too.
Yeah, we had about 250 people register. Obviously, some of those did. Of those, I think when we sent out our final request for participation, we were around 150. So at that cutoff point, I think there were about 100 more attendees that didn't get the opportunity to participate since we wanted to have the data and have time to analyze it.
Right.
But I do see some folks expressing interest, so maybe you and I can talk about that after we wrap things up for the workshop.
Sure.
We'll have everybody's information. Okay, well, if there are no further questions, I think we'll thank you, Betsy, for, yep, no further questions. So thanks, Betsy, for putting this together. It was really informative, and we really appreciate you taking the time to share with our group today.
Yeah, I appreciate all of your help going into it. It's been really interesting to learn, and like I said, I think there's probably more to get out of it as we iterate on the survey itself too and get more replies.
Yeah, so I'm going to go ahead and launch the poll. So if you're interested, Betsy, in hanging in there, we will share the data that we have with you. So folks that are in attendance, we've launched the first poll, which reads, does your system usage fall in line with the survey sample for those with your same number of CIUs or SIUs. We'll keep this poll open for about a minute, and then we'll share the results.
Okay. Yeah, I'd be interested to see. I wonder how the audience differs, those that answered the survey and those that are here.
Right, yeah, I'm looking forward to it as well.
So Betsy, have you guys done any cost comparisons with other data management software? Is it like a la carte where it's customized per program, per particular size of program, or and how does that compare with other management software systems that are out there?
Are you talking about Swift Comply in general, or just in general looking at program management systems?
Sorry, I was on mute. Just
Sorry.
program management systems as a whole, probably.
Yeah, I mean, I think there's different ways that folks break down that pricing, and typically it's either by users or seats, and that can be across different stakeholders within a system. So that could be your staff, it could be other folks that need to see that information. So typically, like I said, the ways they do it would be by number of users or seats, or by size of the program, probably in terms of SIUs or CIUs. So how much data are you managing and how much is coming in and out? So I think those are probably the two main ways that folks size the pricing for systems.
Great. We did have another question come in. Did agencies that used pretreatment or customized software also use other methods, for example, paper or Excel, for some tasks, or were they able to handle?
It looked pretty distributed. So there was not one answer going across all the features for each program. It was typically a mix. They would use paper for 2 features, Excel for 3 features, custom for another 4 or 5 features. So it did seem to be pretty mixed. And I'm not really an expert in why, as I keep saying, but my guess is that some of that is determined by existing systems or use of other systems within the city. So something like permits or lists of new industries, those things may live outside of the pretreatment program, and that may be why they are treated system-wise in a different way.
Okay. So our first poll, does your system usage fall in line with the survey sample for those with your same number of SIUs or CIUs? 76% of those who took the poll answered yes, and 24% answered no. Our second poll, does your system usage fall in line with the survey sample for those with your same number of FTEs? 74% said yes, and 26% said no.
I see. So, it's pretty similar to what we found in the data, that the two indicators aren't terribly different. One, SIUs is not a much stronger predictor than FTEs or vice versa. So that's pretty consistent. And we'll have to see if maybe about 25% that feel like their system was outside of that, whether that's just data or whether they were not participants in the actual responses to the survey.
Mm-hmm. Well, I think it'll be really interesting to see what we get moving forward.
Yep, and we can talk further too about If anyone has interest in seeing any other parts of the data, like I said, it's all anonymous and available. So if there are questions about any of the detail of it, we can certainly make it available.
Yeah. Okay. Well, again, Betsy, thank you so much for putting this together and sharing with us today. We really appreciate your time.
Yes, thank you. I appreciate your help.
Yeah. Well, we'll go ahead and wrap up day 3 of our Pacific Northwest Pretreatment Workshop. I just wanted to send out a reminder about our virtual networking event on Thursday, November 12th. Send me an email if you would like to attend this, and we'll get you signed up for it. And again, thank you so much for coming today. Please take the opportunity to complete the survey that we send out after the workshop. And we'll see all of you guys on Thursday, November 12th for day 4 of the workshop. Thank you. Bye-bye, guys.